runs so that I can better troubleshoot any issues he has. And like share a source tree. Both have the shared source tree in case something on the NetBase side needs to be fixed that is unrelated to what he's working on. Maybe I can like incorporate the fix into that tree and push it to his repository and so. So our build system, NetBSD build system, this is really like driven by build.sh these days. That is in the top of the source directory tree. And we do cross compilation by default. So even when we run natively on NetBSD, so there's really no requirement to build on NetBSD. And so we need to tell build.sh for which machine it should build, like machine like AMD64 or what, Alpha or what, EVB PPC for V, or what was it? Yeah. And it generates like a lot of artifacts, object files from the C files, like pre-formatted man pages, links the object files into like binaries for the programs and libraries and stuff. This is all. And then we put them below a directory called object. I put that object, but this is not exactly that. And then, so in the build system uses first cross tools that go into something we call tooldir. This is actually a shell environment variable. And like tooldir/bin have the executables used. And we put that into object tools and share that between actually different machines. I do that, it seems to work. Some people say there were bugs. They ran into bugs with that, but I haven't seen anything, noticed anything in a couple of years. And I share the tooldir because I want to have the tooldir bin in my path so that I can run nbmake or nbconfig and all these, so some of the cross tools and speed up things. So then the next thing we have like is object.dir. This is where all these intermediate files, what the compiler output and stuff goes in. And when we install the stuff, we put that into a destir, which mirrors the actual file system hierarchy. It's like what you go from the root directory down there when you do a base install that gets installed into the destir. And in particular, there are header files and libraries, and they are used during the build. Install there, and then when you make a release and generate installation images, binary sets, source sets, and stuff, that goes into a release dir. So we put like the object dir. I put into object $machine because it's machine specific. The destir is also machine specific, and I use the release dir. For some reason, I also have it machine specific, although it is not really machine specific. You can have like, because we collect them all in subdirectories actually of the release directory. But it's maybe easier to get, I don't know, seemed to be more convenient at some point in time, and I stuck with it and really haven't given a lot of thought. So these build artifacts are really like they are ephemeral. You don't need to keep them, you don't need to back them, you can like just remove them and recreate them by running the building. And sometimes even you need to clean slate because we changed something in build system, and I don't know, that is, and then we have like, that leads to errors that aren't fixable, easily fixable with the build system, so we resort to just deleting the object directory or the tools directory or the destir and start the build from scratch. So build.sh is really brilliant. I really like it a lot, but it's really a big hammer. When you run it, it only works from the top tier directory on. It goes through the tree multiple times, first to make object directories, then to make sure that the include files are installed, and it starts building the libraries or seeing if the libraries need to be rebuilt and installed before it can build binaries and stuff. So that like takes a lot of time. And when you're hacking on something
you're working in a directory or maybe 2 or 3 directories, if there's something interrelated and you only a couple of files changing, you do not really want to scan all the huge tree for rebuilding that. And that means you need to invoke our make in there to just nbmake $machine, because it's machine specific. nbmake $machine is a wrapper, so nbmake AMD64, for example, is a wrapper that captures like the tool dir, the object dir, the desk dir, release dir variables, so you can just invoke that to like make clean, make depend all, make install, make. And so I want todir bin in the path for that to be able to use that. So this is a while ago I discovered direnv, which is a tool that you hook into your shell, and whenever you change directory, it looks if there is an applicable envarc file and executes that in a sandbox environment, and you can set environment variables. Usually, typically any environment actually, but also it's really good to prepend, to fix your path, like prepend stuff to the path that are in there when you're in a particular directory or below that, which I use for the todir. And if you go out, change to a different directory, just removes that, undoes the changes. And if you have like working with multiple source trees with different NetBSD versions, you need like different tooldirs when you change into these directories, and that is really convenient to set that up. And so then we have like a couple of helper scripts, because like these command lines tend to get long, and shell history, stored shell history doesn't work for me. I have many windows usually open, and I tend to lose that, what was in there. So I want to have that stuff in shell scripts, also to make the common options like shorter, so that I don't have to repeat them as much. So what we actually build, like when we're building on non-NetBSD, we need a working compiler toolchain, and as of this summer, GCC 12 was okay, and on macOS Xcode 16.4 works. GCC 14 was giving trouble because it uses a newer C standard, but so you need to really, you needed to have like GCC 12. I don't know how the situation currently is. We have recently incorporated GCC 14, but this affects only mostly the build of the tools. Of course, you need to install direnv, probably Git CLI tools, or maybe CVS if you want to use CVS, or Mercurial if you want to Mercurial. And you need to use a shell that you can hook direnv into, like the NetBSD shell. I never tried it, but it hooks into the PS prompt, or the stuff that the shell does when constructing the shell prompt. And so Bash works, Sish works. I think TC shell works too, but I don't use TC shell. I used to use Sish for a long time, but and I figured out like remembering like Sish syntax, which is also like for loops and stuff like that. This is like too difficult, and then if I want to put it into a script, I have to rewrite it for shell syntax. So when you use shell anyway at first, but because I use like Bash and Sish is using, I use that because we use that anyway. Something like that. I use some non-POSIX syntax for IO redirection to make things easier. So for such a development environment, so we actually need a project directory, and name it whatever. Let's use NetBSD, and then we have like standard directories tree in it, subdirectories in it. We use source for the source tree, object for tools and build artifacts,
VM for virtual machine related files. I use that logs for log files because keeping log files is kind of like important. Build out sh output is large, and so for the weekend I looked around and I found some files that are like 250 megabytes and a couple of them that are actually more than 500 megabytes, and actually even outputting that like to your terminal, to your graphical terminal, and rendering all that output, which you're not going to look into, which doesn't fit into the scroll back. This takes up a lot of time, slows down the build actually sometimes, depending on that. So you really want to have that in a log file, and then you're only going to look at it typically when there's a build failure, and then you use like less -n. Also -n because you don't want less to count how many lines in this 500 megabyte build files or stuff. So I have the scripts directory, which I use for the scripts that I use in my environment, and actually also a config directory where I have some configuration files that I use inside the VM, shell startup scripts, etc hosts, and stuff like that. And then, of course, you need the .nvrc file that Dirent uses. Sorry, so this is the actual layout. So it's object VM logs, and so how you create it. A couple of easy commands: make the net residue directory, make some object directories, clone the dev scripts. They are on GitHub. I have this dev-scripts.git actually, and dev-config.git, and that sets up these two directories. Then you have, of course, to extract the source somehow, which will take a file. Actually, I log the output of CVS checkout or CVS update. I log that, and I actually also have script that only grabs the interesting stuff, like which files were merged, which were conflicts, which were removed, and stuff like that. And I wanted to see, because that is like annoying to figure out on all the directories that it prints. Because like CVS, Git and Mercurial work locally, but if you want to see what has changed, and then CVS goes again over the network to the remote servers, this takes a lot of time. So looking into the output of the update, what was actually merged in conflicts and so on, is really much faster. So the direnv control file. It's really easy. Like we use set the TD variable, which stands in for top tier, and as you see, naming is hard. I don't like top tier as the variable, but TD is probably also not a good one. This incantation is, we come to that later. And then I path add scripts. That adds like relatively works for the local directory, adds that to the path, and I path add like the tool directory. And for ZVS also I export the the ZVS RSR environment variable so that I can use CVS to commit to the tree. Hopefully that is no longer, that will soon be no longer necessary. So direnv doesn't execute any random nvrc file. So it actually says, well, I haven't seen this file. Is that actually what you want to run? And you have to direnv allow it. And if you any make, then records a hash of the contents. And if you make any change, it asks you again, and you have to direnv allow it explicitly again. So this is kind of safe, I think. It's reasonably safe. And also you don't pick up like nvrc files from remote directories and stuff. So then when we're done there, you can like start checking out if the build works on the Mac or something. And then the usual thing is, the critical thing is can you build the tools? Can you build working tools, or is there something, because that uses the host compiler? And okay, you cd into the source, and we have like the scripts directory on the path, so we can just use
runbuild.sh or comma runbuild.sh. And then, for example, AMD64 tools, and then keep the log files, and this ampersand greater is the non-POSIX IO redirection syntax that uses, because otherwise I would have to redirect it first and then redirect the file system, redirect standard error to standard, no, standard error from standard in later, if that is then at the end of the line. Comma y by mmdd is just like outputs, does what it does, invokes date with the correct format to print like y, the current date in year, month, day format, but it's just short to type, and then what? So I have that in the log file, and if something is wrong, I just go and inspect that. And so, like, when it fails, runbuild.sh sets up some standard parameters. Of course, it sets like the object directories according to all these, the object dir, tool dir, release dir, and destdir variables according to my conventions, and then it figures out actually how many CPUs are online and uses -j. So we have a parallel build out of the box, and it uses actually always supplies -U, so because we are always doing unprivileged builds anyway. And but then you get the parallel build output, and if something goes broken, you have like the build error somewhere, and it's really hard to figure out. It's not even at the end of the make file. You have to figure exactly out where it is, which is it's a bit difficult sometimes with NetBSD make. And so after you have a failure, it's best to run the build again with J1 to have a non-parallel build, and then the error is at the end of the file, and you actually can see what it goes. And you also want to use like -u to do an update build, so that it doesn't go in and remove anything that actually builds successfully, build it again. So you just want to like do an update build, just get to building to the stuff that actually failed recently. So these -u update builds are relatively free. Then you see a new log file with a new serial number at the end. And then that's why you use the ampersand greater redirection. So you can just like Control P or recall the last line, and then I'm at the end of the line and can update. This is a common operation for me, and so it was useful to optimize for that. And when you have the tools successfully built, it's a good idea to maybe start building a release and see if that goes. And yeah, build log gets really large, as I mentioned. So you have to build a release, and actually you only need to, don't even really need to go through that. You actually do just need build.sh build to populate the destdir if you want to change root into it then later. So I'm using QEMU to do testing now, since recently it has like hypervisor framework support. Before that, it was like, it didn't have that, so you would have to be like a software emulation of the CPU, which was much slower. QEMU command lines get quite long, easily like 200 bytes or more, 200 characters, because you have to put all these devices together. And I've put that out into a run QEMU script, which also has some conventions, like it currently defaults to using a NetBSD 10.1 release. Because we have binary packages for that. And it actually wasn't important to have like a /current to run from /current, because we can boot a current kernel on and with the 10.0 userland, and if you change root into like the destdir, then you're running like the current environment anyway with the kernel that supports it. So that isn't really important. So it knows how to
So there's a little bit of magic that it does. So it looks for NetBSD 10.0 AMD64 ISO image in the VM file currently, uses that as the ISO, as the file for a CD-ROM in QEMU, and creates a NetBSD -10.0 root image, or uses that by default. And actually, if it isn't there, it creates one with QEMU image, creates a QCOW2 file that can grow up to 10 gigabytes, but it's actually much smaller. If you do a full installation, or like full installation without X, it's about uses about 3 gigabytes or so, and sets up a couple of devices you need. It sets via RNG, because we need a random number generator. Actually, we need entropy, working entropy. It sets up user mode networking, so you can have network connectivity. Can now also have CAN SSH into that thing. What else does it do? And then I have shortcuts for the console selection. And so like you have the -C cursors option that selects a VGA console but emulates cursors. So I can cut and paste stuff out of it and have text output, and don't need to deal with like images and screenshots like if you use a graphical console. Actually, I would also you can say -C and then no graphic, then it disables the graphics console. It sometimes gives you a serial console, or -C 0, and then it does the QEMU setup so that you run with a C serial console. But NetBSD 10.1 ISO is with serial console is kind of like that causes trouble. So I think for installation you need to use -C cursors. And so there's a couple of command line options that it accepts that are shorthands for like longer QEMU stuff. And then with --, it stops option processing as usual, and the rest is passed verbatim down to QEMU. Like this -boot once equals D is so that it boots from the image from the ISO instead, and then after that, well, then boots up the install image, goes into system installer, and then you need to install NetBSD on the image. Then you tell it to use the entire disk. You do want to install debug sets, because without debug sets, GDB doesn't work right. At least then you want to enable SSH in the installer so that you can SSH into. You want to create a non-root user that is in group wheel so that you can SU to root. Of course, this is just like personal preference, and then you can also like SSH into root, of course. I want a sudo package install that I then configure so that I can do passwordless sudo, because it's more convenient in the shell, and then you need your SSH keys to the authorized users file for root and the user that you created. What is that thing? So then you can like start after that's done, you reboot DVM, running QEMU -C cursors -SSH, and it configures like port forwarding from port 2022 to the SSH port inside DVM, which is convenient, and you can just connect to localhost port 2022. I actually have a snippet for SSH config, so I can actually do like SSH NBVM, and goes to that port. Okay, so we want to test the stuff inside the VM. So we have like we probably want the sources, because when we want debugging, we want to see the sources, and or we want GDB to show us the sources actually. So we need to export it as shared folder into the VM, and we need to export the object directory with like the actually object dir inside it and the destir inside it into the VM, and then so we can change into that, so and run binaries there or change root into that. NetBSD has a 9p. The 9p file system these days, which is nice because you don't need to do any privileged configuration on the host side. You can just tell QMA, hey, this is the directory, export that as an 9p via 9p, and inside you mount it, and then you're done. You don't need to configure NFS, need to do anything about, know anything like about network addresses or how to configure network. And but you need, the setup is a little bit more complicated, and so I have like created the -- fsdev option, where you tell it just the directory and whether it's like read-only or read-write exported, and then it does the right incantation for QEMU to actually export it as a VO9P device. And you can have like more of them. So typically you have like source and object and do that. And inside the VM, this is like really easy to mount, like kind of like with that. And you can change into, then you can actually change into the desk there or into the object there. You can run the binaries from there. But some operations are, it doesn't work completely. If you do ls-l, you get an error message. And if you try to open a device special file, then things really go sideways. And that's probably also the reason why you can't change root into the desk there if it is 9p mounted. Because I think the linker still needs dev0 to map in. Dev0 is device special files, and well, yeah, okay, so that doesn't really work. So that was last year state basically. And
is it better now?
I haven't contacted. I don't know who is developing that. One of our Japanese guys, but Ozaki R. I haven't like talked to him about that, and I haven't filed bug reports yet, but I have notes to do that or look into that. But I haven't. Well, you know, like too many squirrels. So it's not better now. But user space networking, you get like if you use user space networking, you get inside the VM. QEMU provides you with a DHCP server that gives you like internal addresses from like the 10.02 network. Typically, you get 10.02.15, same as, that seems to be a convention. VirtualBox does the same, other things, I don't know. And interestingly, so it uses slurp to do that. And the slurp is basically the packets that you receive over sent over the interface. They get converted, like sent over sockets from QEMU to the outside world and also get back in. And you can contact the host at the IP address, IPv4 address 10.0.2.2, which turns out to be, translates on the host side to connection to 127.00.1. And this is convenient because then you don't need to know anything about like what IP addresses are used on the host. And then with NFS, we can configure ATC export to export the relevant directories only to the loopback address, which is then really convenient. Like this is like what you need to do on macOS, and I map everything to my local user ID. Of course, you have to know what the actual path is, or you can just export, like, say, the project directory and then all the subtiers, map everything to my own user ID, even root, because, like, I'm just executing programs. I don't need setuid stuff, like, so this is, like, convenient. It's also, well, it's exported to localhost, and then you need to tell it that we don't need to come, mount requests don't need to come from a reserved port because we can't actually configure that, and then it works. And then, like on Linux, you do it like this way. Leonardo tested that for me, and he actually tested it on NetBSD also, but I didn't put it in. And in the VM, you can actually just mount it with like going through that address and then it comes in and then you actually, then is normal change root and it works and you can, normal NFS mount and change root works, device special files works. This is anything that, so people say, yeah, user networking model is slow and like, but you know, in practice, it doesn't really matter. We're not doing stuff that is really using a lot of bandwidth or critical or stuff. Okay. So this is the basic stuff that you can do inside and what you can do and what you can debug inside. And the next thing, do we need to do anything? No. So the next interesting thing is, especially for developers, you have like multiple source trees. Maybe you have a Git checkout and then you need a CVS checkout to commit stuff back currently. If you want to deal with pull-ups, you need checkout sources from older releases, and that maybe it looks then like that. We use like source 9 or source current, for example. The thing is, we can't use then a common object directory, so I just put the object directory into the source directory, like I've been doing for I don't know, like since for a long time, and the rest is basically the same, but you have to use an NFRC file in the source tree to configure that a bit. And that is actually relatively easy. We set TD and source up the upper.nfrc. And this is why the TD was set in the project directory. In the nfrc, TD was only set if it wasn't set already. So you do that, check into that, do the direct allow, and you have like the tool working, you have the scripts working, and then you can just continue with all the stuff that we did before. Also, you can run QEMU from the top of the source directory because it knows to look into .vm, so that's like convenient. And yeah, so this is a little bit more about run build.sh. So first parameter is always like the machine, so it doesn't even have to use a minus -m option that you use with build.sh, and sets up the J -U, -O, -D, and -R options, and does unprivileged builds, uses all the CPUs in parallel, as we say, and this is like typical usage. And passes the rest of the arguments just straight through to build.sh. And run QEMU is also like a little bit like you have run QEMU specific options, and then minus if you need, and then QEMU options that get passed through QEMU. These are the common options: -C to select the console, -root image to select a specific root image file, -root size to set the size. You can -M to set the memory, -ISO image to select a specific ISO image if you don't want to have it auto-configure that, -SSH, so that it sets up the port forwarding. Then the -FSDEF to export 9p file directory, so you can give a directory, then maybe a tag that you can see actually inside on the VU9p device, and whether it's read-only or read-write. Defaults to read-only, if I remember correctly. And this is basically that. And then we have still YYMMDD that we talked about, and make object, which creates an object directory and marks it as not to be backed up, because like on the macOS you have Time Machine running and you don't want to like back up, have snapshots of gigabytes of ephemeral data for every half hour or every hour or whatever, and then maybe spool it to this. That takes a long time.
You seem to have a Y3K bug there.
What?
You seem to have a Y3K bug lurking there. It's going to bite you in a little bit.
Where?
In your YYMMDD script.
Well, yes, probably, but then so does have date, because what does it do on the %y format in?
It's actually a Y100 bug.
Yeah. Oh, sorry, Y2.1K bug.
Well, I'll let you guys deal to it when you get to that, but I'm not around then. Certainly not around by then. So yeah, well, that's true. But all of this is, all of this is just work in progress stuff that I figured out and probably subject to change. But I really wanted to change this, and references. Taylor's excellent. How to get started hacking NetBSD, which covers all the other details about hacking on getting started hacking on NetBSD. Much more stuff than what I have here. It's really good. This is just complementing it. And if you want to look up more about direnv, it's at direnv.net. And wow, almost 5 minutes left. Any questions? Yeah.
Hi, thank you. Not so much a question, there just was a comment from Reino Sandijk talking about the build errors, and he mentioned the error command, which I had not heard of until he had just mentioned that. We have that in base, and that looks at error output from typical tools, compilers, and so on, and that apparently does a really good job in even figuring out errors in build sh-j20 output. So that apparently is useful. I had not known that, so that's kind of information.
Yeah, I haven't used it. I actually like he mentioned that this year on the internal chat, and I was thinking, oh yes, I remember that from reading old Unix man pages, really printed paper man pages, maybe V7 man pages, or I don't know, really all that. In the 80s there was an error command, or somewhere maybe in for FreeBSD or something there was an error command, and but I haven't used it since.
Yes, I just looked at the man page and it says the error command appeared in 4.0BSD. So,
4.0BSD, yeah. So then it was I think the first BSD I could log into was something like 4.2 or something. Yeah.
You run macOS, so I suppose yours is an ARM64 computer.
Actually, right. I'm still on AMD 64.
Oh, okay. So the question doesn't apply because I wanted to ask if different architectures could get in the way of the workflow.
No, not really. No. Anything here that should also work on ARM MacBooks. Well, you don't want to use AMD QMA. You don't want to build for AMD 64. You want to build for EVB ARM 64, and you want to use the QEMU system AH64 actually, and use hardware hypervisor virtualization framework for accelerated support for get really fast things. And it isn't in there, but it's sure, it should be able to do that. If I get the need to that, I'll surely change the stuff so that it works that by default, so that you don't even have to do that. But if someone else does, I accept pull requests, of course.
So I've used this not with Christoph scripts, but manually. It works. This is ARM. Very cool. Thank you.
About the what was it, 9PFS? Is that what it's called?
Yep.
Yes. You mentioned that change routing in that is an issue, and you guess that might be because of device files. Could you do another mount? Could you create a dev inside that?
Yeah.
And then create those device nodes there? Do you think that would work, perhaps?
Yeah, I have. Actually, yeah. Actually, so I had that on the back burner, and for some reason I didn't have time to really think about it. And literally the other day, it occurred to me, well, I could union mount /dev to dev, and maybe you could also do union mount /root's home directory into the change root, and union mount maybe your home directory or etc or whatever you need to into that, and then run the system in there. Maybe start even SSH day in there. Of course, you need a different port or something, then really SSH into the change root. Also, if you want to really change root into
change root into the destier, you need device files. You need def populated. And so either you union mount /def into there, or create a tempfs on top of that and run makedef in there, or on the host you can use nbmakedef is another one of our cross tools to create like NetBSD compatible device special files with the NetBSD, the correct numbering for NetBSD in of the major minor numbers in the desk there. And it is but when you do that, your desk there is a little bit, you have extra files in your desk there, and you can't do a build release after that, not with additional options, because it says, hey, there are files that are not expected in there, and I'm not building the sets. Then you need workarounds. Oh. Okay. Oh, thank you for listening and coming.
Get a speaker gift. It's a necktie.
Oh, thank you.
Yeah. Thank you for the talk.
Yeah, sure. You're welcome.
There will be a family photo in 15 minutes.
All right, so I guess I can get started. And if it's like my previous talk in Canada, I need to use every second I have. So my name is John Baldwin. I'm here to talk about ELF things and linkers and loaders. This is actually kind of a continuation of a talk that I gave in Canada where I kind of started on this topic. So that's hence the title. It's also a reference to a sequel, as it were. So we'll talk about a couple of things. A few of these, because this kind of builds on some things I talked about before back in June, and I'm going to kind of do a little bit of review at the beginning just to make sure we have the right concepts at the start before I then kind of introduce the new topics I want to talk about today. So I'll talk about a bit about what the problem that we're trying to solve with linking, a little bit about what relocations are and what they're used for, as well as comparing some kind of older code generation models, PDEs and PICs. And then after that'll kind of conclude the review portion, and then we'll start tackling some new subjects that I didn't cover before. The first one will be Pi, which is an alternate code generation model from PIC and PDE. Then I'll talk a bit about indirect functions, and then a bit about kind of how runtime loading works, in particular the different data structures that we use inside of ELF for runtime loading as opposed to static linking. So the problem that we're trying to resolve with linking is that source code is written in like prose, well, semi-prose, but we use names for symbols that we understand. They're like ASCII names like printf, things that at least resemble strings. But when a program is running, machine code doesn't use strings to name objects. It uses addresses as kind of its name. And the problem we're trying to resolve with linking is how do we map names that a programmer generates into addresses that the machine needs to use when it's running. So one of the tools we use to manage this are things called relocations. And in ELF, which we're going to kind of focus on for our talk today, in ELF, relocations are a data structure that describe the kind of patches we need to make to an object as we're linking it. So in particular, the compiler generates some object code, and then when we're linking the object code in the static linker, we're going to need to rewrite some bits of that object code. And also at runtime, we can do that as well. And so patches can do different things. They can rewrite parts of instructions. We can also populate data. So there are things that the linker might generate that are arrays of pointers, and we can populate those pointers at runtime. So we have two types of relocations. Static relocations are things that the compiler emits when it's, or perhaps the assembler, when it's generated in an object file that provide instructions to the linker about places that need to be patched, instructions that need to be updated once we've finalized the addresses of symbols. And dynamic relocations are similar. They use the same data structure as in ELF, in fact, but these are not generated by the compiler. Instead, when the linker consumes static relocations, it may decide that I don't actually know the final address of this symbol. And in that case, it will generate a dynamic relocation, which tells the runtime loader something else, a way to patch the actual final address of the symbol once we know it at runtime. For example, when you have a reference to an external symbol that will come from a shared library. That has to be resolved dynamically. So that's kind of what relocations are, what they do. So I've already kind of mentioned it a little bit, but in ELF, we have different kind of modes that we'll use when we're generating code. When we're taking assembly and actually outputting object code, picking which instructions we're going to use, what kind of data accesses we're going to use, for example, or addressing modes. And two of the older modes that we use in ELF are PDE and PIC. So PDE is kind of, I think it might be the oldest. It seems to be the simplest. And it stands for Position Dependent Executable. So historically, this has been used for things like static executables. Static libraries, kinda. Static libraries aren't really libraries. They're just a tarball of object files. And dynamic executables can also be PDEs. For PDE mode, the thing to keep in mind is that the address of an object when it's going to be loaded into virtual memory is fixed. So we link the object to run at a fixed virtual address, and that is the address, the end. Like your entry point is at a fixed virtual address, and the OS has to load the binary at that fixed address. And so the generated code assumes it's going to run at a fixed address. So we might, for example, back at the compile stage, if we need to load the address of a symbol, for example, to use as a pointer, we may assume that we can treat it as an immediate, using like a load immediate type of instruction based on what kind of architecture you have. PIC stands for position independent code, and this is a different way of code generating. It is used in shared libraries. So the main thing about PIC that's different from PDEs is that whereas PDEs are linked for a fixed virtual address, PICs are designed to be loaded at arbitrary addresses. They're relocatable. So that means that they don't hard code absolute addresses of symbols. They will use PC relative accesses to symbols. They will use some kind of offset relative to the current instruction pointer to derive the appropriate address to use for symbols in places. Or we will use things like, we'll have generated code that tries to read addresses from a table that the linker is going to generate, which we call the GOT, or the global offset table. Function calls can also add extra indirections similar to a GOT. The linker will actually generate stubs when it's doing the linking process, and the generated code doesn't call directly to a remote function. Instead, it calls this stub that reads the real function pointer out of yet another GOT. So that's kind of some of the differences between PIC and PDE. So when we are using PDE, originally, when PDEs were used for static executables, that's a pretty simple thing to reason about. When you're linking a static executable, all the symbols get defined at static link time, because you find all your symbols. If you don't find a symbol, that's a linker error, and you don't generate any output. But when you're generating or linking a static executable, you find all the symbols. You know exactly what address they're going to be at. You can fully resolve all of your kind of outstanding static relocations and ensure that you have a valid virtual address to use for any symbol. With dynamic executables that are PDE, that gets a little more wonky, in particular because the compiler still believes it's generating a static executable where the addresses are all fixed. But some of the addresses for a dynamic executable are not fixed. So if you're a dynamic executable that's linked to PDE and you're going to call printf from your library, printf symbol isn't known until runtime. So how do we deal with things like that? So one of the first questions to think about with PDE when using dynamic executables is how to handle a branch to a function that lives in another library. And the way we resolve that is at static link time, we can insert PLT stubs just like we did back for shared libraries in PIC mode. And your generated code can be patched to always call directly to that PLT stub. And we can use a GOT entry that gets fixed up by the runtime loader to actually call printf in your shared library. Another example, and this is one of the ones that gets more messy. And I went through this in more detail in Canada if you want to see a nice animation of how terrible and icky it is what happens if we have a dynamic binary and it's referencing like a global variable, but that global variable is defined in a static library. And it's not just reading the value, it actually needs a pointer to it. So it needs to take a pointer to this global variable and pass it to some other function. Well, you don't know what address can you use. Like if the function, if the variable you're taking reference to lives in some shared library that you don't know what it is yet when you're linking the executable, you have to come up with something. So what do? We do this thing called copy relocations. And the way copy relocations work is at the static linker we know, okay, we have a reference, we need to take a pointer, so we need a valid address in the executable, a static address, for this variable. So we will allocate, we can see how big it is from the shared library that we're looking at. So we allocate space for that variable in our BSS section. And we'll call this kind of like x prime, for example, if we're linking against a variable named x. So we'll allocate space for this x prime. And when we start the executable up and we load the shared library at runtime, we'll copy the value of the real x in the shared library into our copy x prime. And then the runtime loader is going to make sure that every time anything, whether it's the executable or the shared library, any shared library, including the shared library that originally defined the value of x, whenever they try to actually reference x, they can't go to the original x. They have to go to the new copy that lives inside the executable, x prime. So that's a little weird, right? We have to make these alternate copies of something and fix up all the pointers to point over into the executable, not to the library it came from. That's not very intuitive. And we have another example of that, which is what happens if you need to take a pointer to a function that lives in a remote shared library. So for example, you want to take a pointer to a function that lives over in libc like fclose, and you're a binary. Well, we have to have an absolute address that we can hard code into the binary when we link it. So what do we do there? Well, it turns out we do have an address that we can kind of use inside our executable, which is we can create a PLT stub, just like we're going to call the function, and we can use the address of that PLT stub to be the function pointer for the function. And that, okay, I mean, that'll work, right? If you call that function pointer, it'll jump to your PLT stub and resolve, and that'll all kind of fall out. But what about this little thing that C wants, which is that every function pointer to the symbol has to compare the same. So for example, I need to be able to write code in my binary where maybe I want to see does ampersand fclose equal some function that libc returned to me when I called some routine that happened to return a pointer to fclose. So the way that works is we have to ensure that everything else in the process that refers to one of these function pointers can't use the address of the real function. They have to use the address of the PLT stub in the executable. So the thing that we walked through in Canada I'll go back. The thing we walked through in Canada was that means that if libc tries to call fclose in that case via a function pointer, not symbol name, it jumps back to the executable's PLT stub so that it can read the pointer to fclose and then call back into itself inside of libc. And that's kind of nuts as well. So let's talk about our first new topic here. What about pi? Because you might have heard of pi as a different way of generating binaries. It's something we turned on in FreeBSD a couple of years ago. So pi stands for position independent executable. And as you can imagine, it's kind of somewhat in between kind of PIC and PDE. So it's relatively recent model that you can use for code generation. It has a relocatable base address like PIC. So pi binaries don't have to run at a fixed virtual address. They can run at different virtual addresses at runtime. So for example, and the linker, which means that the linker knows that, well, okay, let me back up for a second. So it runs at a relocatable base address, but it is optimized. And in particular, the way we optimize pi compared to a normal shared library is that we know for an executable that any symbol the executable defines itself, if it actually has the function or the data variable for a given symbol, that can't be preempted by some shared library because of the way the ELF linkage rules work. So if it's a symbol that's defined in the executable itself, we can maybe avoid some of the overhead, and I'll get into that a little bit later. In particular, this is required for you to use ASLR, because ASLR depends on the fact that we're trying to pick different addresses for the binary to run across different runs. That can only work if the binary is not hard-coded to run at a fixed virtual address. So in the case of pi, one thing we do is we always use got indirection for data variables on Clang, but not GCC. Yes, at least the version last time I checked, GCC with Compiler Explorer, this was still true. Which means the first kind of weirdness I talked about with PDEs that were dynamic executables, copy relocations, where we had that X and X prime, that problem goes away. Because the code model, when it's generated by the compiler, assumes you're going to read via the GOT. So it can always go find the real pointer to X in some shared library at runtime just fine. Both GCC and Clang also, by default in Pi, always use GOT indirection. So they're always assuming they're going to call through a PLT stub to get to for a function pointer. In particular, they assume they're going to have to read the function pointer out of the GOT, which means this weird thing where we would use the PLT stub in the executable as the function pointer, that problem goes away. So Pi gets rid of some of these kind of weird quirks.
So it works more like the traditional double origin relocation on like main frameworks where you have a table of contents and everything goes to the table of contents.
Well, sort of. I'm still getting there. It starts off that way. So let's look at what the compiler outputs, and then we'll walk through to what happens at the end. So I had this is kind of similar to examples I had at my previous talk. So we had this little function that we had done to model what happens when we're doing access to remote symbols. So you have a remote function call and a remote data symbol. And you can see that when we're doing Pi access with GCC, we're still going to actually use an absolute address, but PC relative for X. So the PC relative part allows us to be a position independent executable instead of a hard-coded fixed number, but it's still the address of X and not trying to read a pointer. So in particular, it's just doing math to add an offset to PC. It's not actually reading a value out of the GOT. And our function call is kind of a normal, we're going to try to go to a PLT stub, and that's the kind of generated code that we get. If we look at this in Clang, it's mostly the same, except that we're now going to read the value out of the GOT, and this is actually the same code you get if you compile with pick. So pi at code gen time looks the same thing as pick on Clang. And so if we want to look at function pointers, they also happen to be the same thing as pick at compile time. So what is generated in the code. So let's talk about something called linker relaxations, because relocations weren't bad enough. So for some relocations, the linker can not only maybe fix up a field like an immediate, for example, the offset that we add to the PC and PC relative loads. Sometimes we can actually rewrite instructions, or maybe knock out instructions, or convert one instruction sequence to another. And the reason we can maybe do this is that the compiler may generate kind of the most generic, but perhaps slowest code gen. And for certain cases, we use the linker. For example, I mentioned that if we may optimize the case when we know a symbol is defined in our executable. So in those cases, we may be able to optimize the code the compiler originally generated to be more efficient code in the resulting executable. I mean, when this occurs, you can think of it that we're relaxing the requirements, right? The original code gen that like always goes through a GOT and always pays the memory overhead of doing a read of the pointer, that was to handle the more generic case that maybe the symbol's remote. But we're now saying, well, we don't have to support that kind of broader requirement. We have a narrow requirement. We know the symbol is defined in the executable. So we've relaxed the requirement. And that's kind of why we named these changes relaxations. TLS is a place that this is often used, because I have not talked about TLS because that was too big a topic for this talk. But there's like 4 modes in TLS, and you can kind of go from the more painful versions down to more optimized versions in certain cases. But pi also depends on this. We depend on using linker relaxations to take some of that kind of slower pick generated version and turn it into something that's a lot closer to a PDE code sequence. So in particular, if we're going to access a global variable like x that's defined inside our executable, we know now that it's going to be in our executable. We don't have to worry about the fact that it might live in a shared library somewhere. We can perhaps rewrite the instruction that instead of doing a read from the GOT, we can actually assume we actually have a direct address itself. And similar if we're calling a function. If we know that we're going to, and this one actually is a much simpler relaxation. If we know that we're going to call a function that's inside our executable, we don't need a PLT stub. We can just make sure the branch instruction jumps straight to the function instead of jumping to a PLT stub that will then call the function. So let's look at how this happens. So I took my sample program from before and I linked it on my desktop, which is a slightly different version of Clang than I had on Compiler Explorer. So it looks a little different just around how we set up the stack frame and so forth. But the input that came out of the compiler is we have this like a move to read a pointer to x out of the GOT, and we're going to call using PLT stub. But at link time, what actually happens? Are you going to show my things? Here, come on. The first thing that the linker does, in this case LD, is it rewrites this instruction that instead of reading the pointer from the GOT, it's actually converted the instruction not to be a move, but to be a LEA, which is a single byte swap on x86. And it's kind of a property of this relaxation that we know we're swapping this particular move construction to an LEA. And it just makes sure that the immediate offset it puts, instead of being the address or the kind of the relative distance to my GOT entry, is the relative distance to the variable itself. So that's a simple, like this was something we were already going to patch. We just change kind of the target that we're aiming for in our patch, and we patch the 1 byte here to change the opcode. And similarly, in this case of the call instruction, we just changed the target of the call. So in this case, we can see the bar function in this executable that came from another object file is actually linked at this address, and we do a PC relative call directly to the symbol without going through a PLT step. So that's kind of the way pi works, is pi allows us to generate something that's more generic to avoid, so it's the case that the symbol is remote, we keep the more generic code and we avoid the weird things like copy relocations. But in the case the symbol is defined our executable, with relaxations, we rewrite the code to get back to kind of the way we would have linked a static executable that was PDE. All right, so now I'm going to talk about indirect functions, or ifuncs perhaps, you might have heard it called. So indirect functions permit you to resolve the target of a symbol kind of more dynamically at runtime. Normally when you're doing symbol resolution, dynamic symbol resolution in ELF, you are calling some function foo, and the job of the runtime loader is to find where foo lives. And it sums, and there's one single foo, maybe there's foos in different shared libraries, but we pick the first foo we find, and that's the foo thou shalt use. But in the case of ifuncs, we're trying to do something else. We actually have multiple versions of foo, and we want to pick a specific version of foo for a given process. So one place you might use this, for example, on x86, you might have certain routines that are optimized to use AVX versus SSE2, and depending on what capabilities your current processor has, that might dictate which version of the function you want to use. So for an ifunc, we have a different type of this GNU ifunc, but the value of the symbol that we get when we do the normal evaluation of the relocation, the dynamic relocation, it's not the address of, say, the function we're going to call like foo. It's the address of a special function called a resolver. And so we do the normal ELF kind of dance to get this kind of address back for our function, but then that turns into a function pointer that we're going to call, and that function's job is to return the real function pointer back to us. So we add an extra layer of indirection where the thing we get from the relocation is the resist resolver function, and we call the resolver function to get the real symbol to use. All right, so yes, that's actually what I already said. And then there's a set of relocations that are kind of a special case for this. You can have ifuncs that are not public exported symbols, but are static local symbols, and you still need to figure out what value you're going to use when you call those. And these I-relative relocations you might see are a way to deal with resolving the final address of ifuncs that are like a static function inside your executable as opposed to a global thing like a string function like Sterling that might be exported from libc. So let's walk through an example of kind of how an ifunc might work in practice. So I have over here some source code. It's going to call memset, and in this case, we're going to see which version of memset it's actually going to call. So the result that we get from our binary when we load it into memory is it's got a main, it's going to have a PLT stub for memset, and it's going to have the GOT entry that goes along with this PLT and our PLT 0 from before. Along with having the PLT and the GOT, this branch instruction in main is going to call down to the PLT stub, and the PLT stub is going to read the target that it's going to try to branch to out of this last entry in the GOT. And that's kind of how we start off when we actually get the binary into memory. So once we start dynamically linking, we have the runtime loader in our address space as well. It has this function we're going to use in a little bit, the entry point for lazy PLT resolution. And it constructs a couple of things. So it initializes their first two entries in our PLT GOT to point to kind of the function to resolve symbols, and like a token, like an opaque pointer it puts to say you're coming from the main binary as opposed to coming from a shared library. And it's going to populate this GOT entry to jump up to the PLT 0. So the very first time you call it, we're going to do the lazy PLT resolution dance. Along with this, the runtime loader is going to notice, hey, you need libc. It's one of the dependencies you required. So we're going to load libc into memory. And libc, among other things, is going to have a couple of functions here. It's going to have a memset resolver and a memset AVX and SSE2. One thing you might notice is there is no actual function there whose name is spelled memset in this case. And in particular, what was I going to say for this step? Okay, all right, I went ahead of myself. So let's actually follow the trace of events once we call into the function. So main is going to try to call memset. It's going to jump down here to the PLT stub. The PLT stub is going to read a pointer from the GOT entry, or the PLT GOT. That's going to point back up to this PLT 0 stub. So the very first time we call, we jump back up to this PLT 0 stub. That reads this function pointer and this data pointer out of these two entries and jumps into the runtime linker. So we've arrived in the runtime linker, and we know we're trying to resolve this PLT stub or this GOT entry for the function memset. And that's what we're trying to do. So inside the runtime linker, we do our normal symbol lookup to say, well, what should we resolve that to? And normally this would, when we did that, it would point to a function named memset in libc. Instead, in this case, the thing we get to is a pointer to memset resolver. But because it's targeted as an ifunc, then we call memset resolver still inside of RTLD. And in this case, it might say, well, you bought a cheap CPU, you don't have AVX. So we're giving you the SSD2 version, and we're going to return a function pointer to memset SSD2 back up to the runtime loader. And then once that happens, the runtime loader is going to take the function pointer to this function, this memset SSD2, store that in the PLT God entry, and arrange on return that that's the function that will actually get called. And that's kind of the process for how we decide which version of memset we're going to call when we're using ifuncs.
Except we don't actually have this for memset. It's
Yeah, I know. You could. But so a couple of things. This is kind of a general slide I wanted to go over that I didn't get a chance to get to in my previous talk. But just kind of an overview of some of the sections that will show up in an ELF file and kind of which types of ELF files they'll show up. Some of these you probably are familiar with, like .text. That tends to be a blob of machine code that get generated by your assembler. And you have those things both in object files and in like executables and shared libraries. You know, .data is writable data, row data is read-only data, and BSS is writable data that is initialized with 0 at runtime. Some other ones that are perhaps slightly more interesting. For an object file, every section in here, whether it's text or data, can have relocations. And the way that we name those sections that contain relocations is .rel or .rela dot and then the original section name. So if we want to find, inside the static linker, we're trying to find what relocations apply to the text file or the text section when we go to an object file. We look inside that object file to see if we have a rel or rela dot text. Or if we need relocations to fix up kind of pointers that are initialized in .data, then we'll have a rel.data or rela.data. .got is the data got, and that doesn't exist in object files, only something that's generated by your static linker. So that holds all your kind of data pointer variables or function pointer variables. .plt are all the PLT stubs kind of crammed together. You have that kind of PLT 0, 1 at the beginning, it's special, and then your array of kind of little stubs after that. And .got.plt is the special got that is paired with the PLT. So this only holds addresses that PLT stubs try to load and call when they're calling a remote function. And then finally, the last two that I've mentioned here, relay.den are the dynamic ELF relocations that the static linker generates and get consumed by the runtime loader. And that fixes up everything but the PLT got. So anything that's in the got, it's just the way you initialize the variables in the got. They're all relocations that are defined in this relay.den. Also fixes perhaps to other sections, sometimes can also be in relay.den. But when you're resolving PLT stubs, those all live in a dedicated table. Relay linker views a file, or maybe even tools you've used with readelf. You might notice there's kind of two ways of looking at ELF files, and this is kind of why. So runtime loaders in particular don't use ELF section headers. So ELF sections are very fine-grained, whereas the runtime loader doesn't quite need to know always the detail about every single header, and it's not the most efficient way for it to figure out what it's going to do. And in particular, for the most part, the runtime loader doesn't know anything about ELF sections directly. Instead, in ELF, we create kind of a parallel set of data structures that describe what the runtime loader should do, how it's going to actually load an executable or a shared library into memory, and how to arrange it to be mapped correctly and apply all the fix-ups. So in particular, linked output files, things like executables and shared libraries, they have an array of things called program headers, and you can examine those with readelf -l. And program headers are intended to be kind of consumed by the runtime loader. That gives it its sequence of basic instructions for how to get started for mapping an executable into the address space. The static linker generates a special section called .dynamic, which is it's like an array of ancillary instructions for the runtime loader to use. It might give pointers to certain ELF sections, but not others, and perhaps how long they are for ones that the runtime loader can care about. You can examine that on an executable or a shared library with readelf -d. And we actually have a separate symbol table. So if you look at a dynamically linked binary or library, it actually have two symbol tables. There's a static symbol table, which is kind of useful for tools like readelf or objdump if you're looking at a binary. But the one that the runtime loader cares about are the dynamic symbol table, which only contains a subset of symbols defined in the executable. In particular, any symbols that the runtime loader is going to need to deal with dynamic linking. So either the names, symbol names for symbols that are exported from the executable, or symbols that we're going to need that are undefined but live off in some shared library. We still need a way to name those symbols. And both of those sets live in our dynamic symbol table. And readelf has a particular flag to let you see just that symbol table as well. So what are the steps we kind of do if we're a loader of some sort, which can include the kernel loader or even the dynamic loader or like the kernel's image activator too, when we're loading an ELF file into memory? So first, the very first thing we'll do as any type of loader is we're going to look at the executable header at the start of the ELF. And it has a couple of things in it. It says what architecture the file is linked for. Like, is it a 32-bit versus 64-bit file? Is it Little Indian versus Big Indian? And so we'll do some initial sanity checks to make sure, yes, this is an architecture I know how to execute, and that, like, I can deal with this Indianness or I can't. So we do some initial checks along those lines. Another thing the executable header has is it also has an offset in the file of my array of program headers so that we can find, and how long they are, so that we as the loader can go find the program headers and kind of read a copy of them into an array so we can look at them and examine them further. So the second thing we do is we use that information from the executable header to read in all the program headers, and we walk over the program headers to kind of get our next sequence of directions we're going to do. And there's several different program headers, but I'll highlight a few of them here. One of them that's primarily used by the kernel is called pt-interp. In executables, this points to a string. It gives the file offset of a string in the file. That is the name of the runtime loader that we're going to use. And the kernel uses this to make sure that not only does it map the executable into the new process address space, it also maps the runtime loader into the address space. And when the kernel starts executing the binary, it doesn't jump to the executable, it jumps to the runtime loader. Excuse me. One really important program header is something called pt-load. And pt-load tells the loader that you need to take a chunk of the file and load it, or a copy of it, or usually mmap is what we tend to do, into a portion of the process address space. So you can mostly think of the fact that every pt-load more or less turns into a single call to mmap. Another one that we're going to care about is pt-dynamic. So pt-dynamic doesn't tell the loader that it needs to kind of map something to the address space, but once you've mapped everything into the address space, pt-dynamic says, well, there's a chunk of the thing that you mapped that includes that .dynamic section that you care about that has more details you need to pursue. So you don't have to go parse ELF sections to figure out where your dynamic section is. This special thing says, here's where your dynamic starts and here's how long it is. So then the third thing we do, after we've mapped everything to memory and we've parsed this table, is then we use the results of pt-dynamic to find the dynamic section, and we walk it. It's an array of these kind of various tagged values, and each one has a type and a value, and those tagged values can tell us all sorts of things. They tell us kind of the names of shared libraries we depend on, that they tell us the address and length of various sections we might actually care about, not all of them, but certain ones that we will care about as a runtime loader, such as where's our PLT got, so we can overwrite the first few entries in the PLT got with the first two pointers it needs. So let's kind of walk through this. This is my last real thing for the day. So we're going to kind of walk through the steps. I've picked userland, and I've not done an executable, but a shared library because it's slightly simpler. So we're going to load like the C runtime library into memory. And this is the file we have on disk. So things in green, you can kind of think of those as ELF sections that are read-only. Things in blue are things that are executable, and things in red are read-write. BSS is kind of special because the way BSS works in the ELF file is we don't actually have bits for it. We say how much address space it needs to consume, but we mark it with a special flag to say there's no bits to copy. It's just something you just need to create zeros in the address space. So there's no like data, there's not like a big pile of zeros in the file for BSS, if that makes sense. So we're going to start off, and we're going to say, on this side, we're going to populate what the actual result is going to look like in virtual memory after we load this library. So we're going to start iterating over the program headers, and we're going to find a pt-load that covers all of the read-only data. So we're going to call mmap. and mmap like this chunk of the file over into the amount of address space that we've chosen. I know, I'll get there. Then we get to another PT load for the executable chunk. So we'll call mmap again. This time we're giving read and execute permissions, so we get text and PLT mapped executable. Then we're going to run into a PLT load, and I'll get into why it's the second one a little later. So we get one PT load that loads dynamic and GOT as read-write. So we do an mmap for that. Then we get a PT load that covers our last chunk of writable data. And it actually says you need to, like, you have this much file data and this much kind of address space. So the way we cope with that is we do one mmap to map this part of the file as read-write. And then after that, we do a map anon to instantiate our BSSS. So we can create 0 back pages to deal with our BSSS. So at this point, we've kind of constructed at least the kind of the raw address space in virtual memory of where all the libc bits live. So the next step we're going to do is we're going to look back in that program header, and we're going to find the PT dynamic entry. And the PT dynamic entry is going to tell us the starting virtual address and the length of .dynamic. So then as the runtime loader, we can iterate over .dynamic and look at all the entries it contains. And two of them I'm going to talk about here in particular. One of them will be a DT relay, and it's got a pair that tells you how long, that points to the start of this relay.din. And this tells us all the dynamic relocations we need to apply for the GOT. So once we've seen this tag, then as the runtime loader, we can actually go through, fix up all the kind of relocations for everything except the PLT. In particular, we'll populate all the pointers in our GOT based on this kind of tag we find in .dynamic. Another one we will run into is DT PLT GOT. This points to the start of our GOT.plt. And if you remember, the first two entries in your GOT.plt are kind of special. They're reserved to be this kind of the entry point to your lazy binding and the data pointer that goes along with it. So we'll use this fact to know that we can write the first two pointers at that address to initialize our PLT GOT. And we'll also have another way that we can initialize the rest of the GOT.plt. So at this point, we've applied all the relocations we need. So we've done all the patches and fix-ups to things inside of our library. But we have one last step to take. And it's related to the fact that we had 2 PLT loads for writable data. So there's another special program header that's defined for something called relrow. And relrow is a step where we know that some of the data that the runtime loader is going to patch, once the runtime loader has finished applying relocations, that data will effectively be read-only and shouldn't ever change. And this includes things like your .got. It also includes .dynamic. For shared libraries, this doesn't change, but for executables, we actually store a special pointer in here for debuggers to use to find the linked list of all the shared libraries in your process. So once we've finished kind of doing our relocations, this special program header is an instruction to the loader to say, OK, now you can take this part of the executable and change its permissions to be read-only. So once we've finished all the relocation handling, we'll do an mprotect to change this part of the address space to prot read. So now those sections are effectively mapped read-only instead of read-write. And from this point forward, your GOT can't change because you're fully linked and relocated. And this is kind of the end result of how libc works in your address space. So we have a BSS that's populated. We have all sorts of changes to our dynamic and GOT.plt, and this stuff is now kind of fixed in stone. All right, I've got a couple minutes left. So some dynamic entries that are kind of common, that are kind of interesting, perhaps, and you can look at these with readelf. DT needed is how we identify shared libraries that we depend on. So for every shared library, we'll have a separate DT needed entry. And the address of a DT needed is actually a reference to a string that has like the name of each library. Many of the ones that define kind of a region of address space that we care about actually come in pairs. So you'll have a tag, and you'll have a tag with size appended to the end that gives you the length. So DT relay was one I talked about. That tells you where you can find your relay.din for all your dynamic relocations outside of the PLT. The PLT is kind of special. It has 3 different ones. It has a pointer to the start of your relocation table for your PLT and how long that is. And then has a pointer to the start of your GOT. It doesn't tell you how long your GOT is, just the start of it. Because the way the relocations will deal with how long the GOT is for you. And we also get some things that tell us our symbol table that we're going to use for all our dynamic symbol resolution, as well as the strings that are used that the symbol table uses to kind of point to the actual symbol name strings, and how long the list of strings are. And there are others besides that, but these are kind of the common ones you might encounter and are kind of most meaningful to the runtime loader. All right, so the last couple of things. One thing to keep in mind is it turns out when we're talking about PIC and Pi and PDE, the default that you use actually varies by compiler and architecture and even can vary by version. So like Clang tends to default on Pi on FreeBSD, but it might default to PDE on other architectures. GCC will probably default to PDE on FreeBSD and Pi on some others, so it can vary. One of the things that some folks have added recently I don't know if LLD does this yet, but they've added a mode called -f no PLT, which doesn't do PLT stubs at all. Instead, it assumes that if I'm calling a function that's remote, I'm going to explicitly read in the generated code from the assembler, I'm going to read the function pointer out of the GOT and call it directly. We play some games with this and the way we link kernel modules on like AMD 64, but this is a way to do it where we don't have to, it's a different way of playing the game, and I think the Linux kernel in particular uses this to avoid having PLT stubs between kernel modules, because in kernel linkers, you don't generally have things like LD preload. Like, you statically figure out what function you're going to call when you load the object, and that's the end. There's not kind of a lazy resolution at all. So there's not really a need for PLT stubs or the extra runtime cost and memory references.
I thought like lazy PLT resolution was already not a thing due to multi-threading issues.
Well, but in kernels, we kind of effectively turn it off. Usually we just write the GOT entry directly if we're using.
Even in user spaces, is the PLT not written eagerly these days?
No. You can opt into it, like with LD bind now.
I thought I had read that they disabled lazy PLT building because it is very hard to get this to do this in a thread-safe manner. Especially not a problem.
It's normally not a problem, because even if you race, you just both resolve to the same function and you both write it.
Well, the problem is the PLT stub entry is so large that it cannot be atomically written. So if
you write a pointer in the GOT. That's all you write.
Okay, so that is
most architectures. So it may be that so Power and Itanium can be weird children, but on
Spark is one of those crazy ones.
Spark might also be a weird child.
The originally one was where you would actually change the PLT stub to do the indirect GOT call. And originally the PLT stub, so the PLT stub in the binary would say like, yeah, here's the symbol index, and now we call it to the linker, and then it would be overwritten.
Even on MIPS, the PLT stub was read-only and didn't change. It was only the GOT that changed. I'm not aware of anybody that actually rewrote the code.
Disables lazy loading. You might be thinking of that one.
Railroad only usually covers the GOT, not the PLT GOT. So you can still have railroad and still have lazy resolution. But in particular in the kernel, we generally don't do lazy resolution. And FNO PLT is really targeted at kind of kernel environments.
Also, the other like C library they don't support. So that for that, then yeah, they just.
That could be. You could effectively decide you want to do LD bind. Like in FreeBSD's kernel or FreeBSD's runtime loader, I know we have more or less a giant serialization lock called the RTLD bind lock that we deal with races in some cases.
It's nice for security as well, right? You don't get a mutable pointer for a function that could be used for an attack. So that's a good reason for disabling the lazy.
Anyway, this is an option to turn off PLTs entirely, and I at least know that kernels are a place that considers using it.
What is the performance impact of using the GOT directly over
It normally helps.
It normally helps because you're always going to read from the GOT anyway. It's just a matter of where you read from the GOT, but you remove a branch and you remove a couple of instructions in the PLT stub. So you effectively probably trim 1 or 2 instructions and a branch.
I mean, the main difference is that the way indirect function call prediction works is that it is predicted to always go to the same place per call. So I would assume that if you have a single call to each function in the PLT, that means there's a single branch predictor slot that has to predict it correctly. But if you have multiple call sites in the code, then each of these call sets has to be trained in the branch predictor, and that may cause
Yes,
performance.
but
maybe
but they will always call the same thing.
yes, but the branch predictor doesn't know that until it fetches it for the first time.
Yes.
So you get more branch predictor
Uh,
usage, and
You have more pressure on the branch.
All right,
branch
so-
cache, but you have less layers of indirection first.
and has high accuracy, yes. So this is why I asked what the components impact is in practice. Like, have you measured it or something?
Anyway, this is, yeah, I'll just put a couple of things because I've got to stop. I'm aware of one book. Someone at Canada had said that Sun wrote some decent books on ELF. I haven't found a reference to that, so I don't have a pointer to those. Some things I did use a little bit, especially more in my previous talk. Compiler Explorer is a really cool tool because you can write a little bit of snippet of source code. You can compile it in different modes and compare compilers. So that's very useful. Masquerade is a person who works on LLVM's linker, LLD, and he has a blog where he writes about a lot of this stuff and provides pretty good details. So he's a good resource if you want to learn more about static linking in particular. So I will take questions, even though they might have to turn the stream off, I'm not sure, for a few minutes.
So aside from the security reasons, is there a reason why you don't patch back the call site so that the original call site gets patched to the call to the universe?
So at dynamic linking, we don't patch the call site, only the GOT. And the original reason for, so the question was about why, I assume the question is about lazy PLT resolution, why do it at all? The original motivation is that for many executables, you might only call a small subset of functions, in particular a shared library. So if you look at like the .got for libc, it's rather enormous. It has a lot of things in it, and so does the PLT got. If you don't have lazy PLT resolution, then when you load libc, you have to resolve every single PLT got entry, even for tons of functions that you will never call. By using lazy PLT resolution, you still have to do some fix-up to those got entries, but you do a much simpler relative relocation. You just add the base address of the library. And you can burn through that without burning near as much iCache and without looking up relocations and looking in your dynamic symbol table. So it's much quicker startup time for many executables that aren't going to use all the different symbols that are listed in a shared library's got PLT. So that's the original motivation for lazy PLT resolution, is that you do much quicker startup time and avoid doing a bunch of work that you're never going to use. So it is a trade-off. And like every runtime loader I know of in user space supports like LD bind now or some equivalent where if you decide for a given process you want to eagerly bind, yes, you can do it. And there may be that some runtime loaders decide we're not even going to do lazy at all. Like you can do that. It's not an invalid implementation. But the code gen assumes you are going to do it.
We got one question here.
Sure.
I have a question regarding the the static indirect functions.
Oh, like static ifuncs, yes.
Static ifuncs, yeah. What's the use case for that?
There's even a special case in LLD to handle calls to static functions. Well, you might be linking libc statically. Mm-hmm. And then you take a function to, for some reason, I don't know why, you might take a function pointer to like memcopy. And you've linked against libc statically, and you generated a Pi executable. So you need to handle that.
Oh, okay, I think I get it. Okay.
How does it actually work? Because you don't have a
So you have a... No, you don't have a PLT. So what happens is, because I actually use this in another context where I've been hacking on the loader for work, there's a separate little thing you can have called an iPLT, which is specifically for this case. You can kind of think of it as the indirect PLT, and an iGOT. So you do end up with a little PLT stub, but it never does lazy resolution. It loads from these iGOT entries that are part of, I think they're at the tail end of your PLT and the tail end of your GOT. And those entries don't have a relative normal jump slot relocation, a normal jump slot relocation in your relay.plt. There's no entry in relay.plt for those at all. Instead, in your like static dynamic relocations, your relay.din, it will have a fix-up to directly fix up the entry in that got PLT entry. So that at static, like when you're linked, it's like effectively LD bind now always for those particular got PLT entries. And in LLD, they call it the iPLT and the iGOT PLT. So you still have to call the resolver. So you call the resolver kind of when you're processing other relocations.
And there's some sort of code that fills in this tables.
Well, your runtime loader does. One of the tricks about...
Runtime loader if you have
so if you actually want this in Pi, you have to actually have a little bit of a runtime loader. One of the things you can do that to handle this for Pi, there's actually a couple of...
Position-dependent binaries which do not have I think it does.
No, ifuncs do not work in PDE. And Pi, what happens, or maybe they do. So there is a thing that we emit a couple of symbols, relay.iplt start and relay.iplt end, that your C startup code can use to find an array of relocations that it has to apply. And you effectively have a tiny little runtime loader bit in your C startup code to do it. All right, I think there's another question in the back. More questions? Or not questions? Yeah, there's a question in the back. Here, I got a question in the all the way in the back, Patrick.
Yeah, hang on.
Hang on.
I don't know what you mean, but hang on, you can hold on.
Can we write our own resolver function? How do we do that?
I'm not quite making it out. Can I write?
How do we write a resolver function?
A resolver for what?
To select the ifunc or.
Come forward.
Is it hard to write an isolver function? No, effectively you declare it as a normal C function, and for different architectures, the calling convention is a little different. So for example, in x86, you get 4 words that come in that are some of the CPU ID bits, and your job is that you're supposed to return a function pointer. So your signature is kind of void star, foo resolver, and then depending on your architecture, some various set of parameters you get. On x86, it's CPU ID flags that are kind of like hard HWCap from at HWCap. On RISC-V, it's a different set of things, or on ARM, it's a different set of things. And you look at those, you're supposed to look at those bits and hopefully not actually have to call things like CPU ID, and then switch on those to decide what function pointer you're going to return.
Unfortunately, you don't even get enough bits.
You may not get enough bits.
You can pull the laptop. You can keep talking.
Yeah, okay.
Let's just pull the laptop and get the next laptop set up.
That's fine. And then there's like a special annotation. We have a wrapper inside of libc to deal with it, where you need to annotate the symbol a bit specially to say it's an ifunc symbol as opposed to a normal function symbol. But it's pretty easy to write. It's just a C function that returns a function pointer. All right, you probably want this now.
Wait, let me mute my phone first. Okay. So, microphone good? Slides? Okay. So, we're gonna talk not about what was talked about last day, because at first I thought I would have the exact same talk, but thankfully we don't. So, this is, I wouldn't say this is a talk really. This is more of a request for comments or request for discussion, because I don't really have, this is not a manifesto or something for how to fix the internet, or it's just ideas I have, I collected, and I wanted to just present a bunch of ideas to maybe inspire some people to do something about this problem. So that's my name. I do mostly FreeBSD stuff, although in this presentation I will show OpenBSD setups. So, yes, I didn't mention the title of the talk, Redecentralizing the Internet with BSD. So, sorry, why redecentralize? I would like to ask Stefano, why, how can I bring it? What made you want to start redecentralizing the internet?
Personally speaking, everything.
Hmm?
Decentralize everything.
Yes. So my issue is that essentially all online discourse, communications, internet posting, e-commerce, movies is all centralized into 5 websites. 6? I don't know. 5 companies maybe. So this goes against Tim Berners-Lee vision. I guess all of you should know who Tim Berners-Lee is, who made the internet to be a decentralized kind of archive of information that people access, and each one has their own individual server. They post files or text or music, whatever, and people just access it. They have their own node of sharing information, and all these are interconnected, and that's why it's called internet. So I guess we can agree that today this is exactly the opposite of what we have. We don't really have an internet exactly. So the way I see the internet is just the equivalent of a medieval map maybe, of sovereign millions of states, I hope not fighting each other in this case, instead of a world empire. That I think is what we have today. So I guess most of you remember the internet as just chaotic, unsafe in some to some extent, but I think we could also say it was a creative place. People had their own websites, they had their own style, they expressed themselves in some way and didn't just use whatever the big guys offered them, which is just an account where you can post some stuff in a predefined format with a predefined algorithm. So people made stuff and made their own existence on the internet. And I would like to give some examples, I guess. I don't know. I don't know about you, but this, to me, makes me want to browse the internet, makes it fun, a fun thing to browse. You go to some webpage and you see really Danny's sense of style. You see exactly what he wants to present to the world, and not just, a Facebook page that's white and blue. Maybe nowadays it's only white, I don't know, where you just have words and nothing else. So, I don't know. You might disagree on the styling choices, but I think it is a good thing that people had the choice to express themselves. That's another website. Another one. That's MSN, by the way. If you go to msn.com today, you will just see the millionth copy of the same format, squares with articles and easy to consume stuff. So that's Pepsi's website, by the way. Okay, to be fair, I think I prefer today's Pepsi website, but it just goes to show that people tried creative things. They didn't just copy what the other people did or what the big companies do, just so they can extract more money and get more clicks, more revenue. It was just about putting information out there in the way that you want to show them. So, problems? As I said in the beginning, just everything is centralized on the internet. Can someone give me an example of something that is not centralized nowadays? one example maybe. Even if it's obscure.
Torrent trackers.
Hmm?
Torrent trackers.
What is this?
BitTorrent.
Torrent trackers. Okay, yeah, okay, so except torrents maybe. Minecraft? Okay. Okay, Minecraft. But this is not what most people do on the internet. So most people use the internet to communicate with people or find information on it, and this is centralized. This belongs to just a handful of companies out there. And I think that's not really okay. And as I said again, people do not really host things. I say websites because, as you'll see later, I'm more of a have your own website person instead of have your own decentralized social media instance person. But still, people don't even host services, let's say an FTP server or a wiki or anything. People just rely on Reddit, Facebook, Twitter, YouTube, and that's it. Netflix maybe also if they watch movies. So you may have seen people who have their own websites, but what is it most of the time? It's just this. Just a landing page that links you to their social media. I made this in 2 minutes. Sorry if it's not aligned properly. But yeah, I think this is, most people can confirm this is what most people do when they have a website. Or maybe they will have, oh, I'm a JavaScript developer, and here's my Stack Overflow link. So I think this, bringing again the medieval parallel I did in the beginning, I think just this is an online form of peasantry. You have your landlord, which is all these big tech companies. They offer you their service, and you just use it. Maybe you even pay them. And you don't really have an existence. If they want to kick you out, they can kick you out. If they want to control what you say, they will control what you say. So really, I don't see the, how can I say that? I think the internet is bigger than ever in terms of how much information it has, but it's all concentrated into one place. And if that place shuts down, that's it. All online discourse then, it's over. You see maybe in countries where they, for example, ban a social media website and then they just cannot communicate anymore. So, yeah, again, I'm reiterating the same point that people don't really, there's not really much existence outside socially engineered platforms, which are also algorithmically engineered almost all of the time to promote noise, to promote, in general, trash. That will get clicks, and so you get more clicks, you get more views, the websites make more money because you watch more ads, and then they sell that information to companies to sell you more products, and then the circle continues. So this, I found it on a, I think it was an article that was referencing Tim Berners-Lee recent project to really decentralize the internet, and someone mentioned that 1.6 billion people log into Facebook daily. I think that's, how much is this? 1/5 of the planet logging daily to one website to do all their talking there. And here are some examples of how centralized the internet has been. So for social media, I guess we have Facebook. I say including Instagram because Instagram, WhatsApp, you know, it's the same thing under the same company. So the same company controls all this. We have Twitter, which is, again, same thing. E-commerce, Amazon, I'm not sure if that's accurate statistics I saw, but I think it was around 49% of all e-commerce is controlled by Amazon. I don't know, is that an accurate statistic? Some people said 30, but I think it's still a ridiculous number that one website controls almost all e-commerce out there. That's a bit crazy to me. Messaging, again, WhatsApp, Facebook. Movies, Netflix. Sorry if anyone here is working on Netflix. Forums, Reddit. Again, how many times people search a question on Google and all they find is just a Reddit post or an AI-generated reply. Like, people do not really post stuff on their own existence of the internet. And the rest, maps, email, cloud, whatever, mostly people use Google. And I know what you will say, okay, but I use my own website. I'm a FreeBSD guy or an OpenBSD guy, and I have my own website and I self-host everything. And I'm really independent on the web, but I think that you're not really representative of how 99.999% of the people use the internet out there. Most people use it, they have their phone and they just have their social media apps, their Amazon app, and they just exist in 2 platforms, that if they shut down, that's it. So I think if I didn't mention it, I probably would get a question that, but we all here know about all this. Why are you talking about that? We all have our own servers and host email servers and whatsoever, but I think that's not what most people do. So I guess we can all agree on that we are not really representative of what most of the planet does out there. So, as I said before, the internet might be bigger in terms of size. It has, yeah, we could say it has all the information possible nowadays. We have articles about everything. We have everyone's thoughts and voting preferences and likings and photos and everything. But it feels smaller. I don't know about you, but to me it just feels smaller, that all this is just 10 websites. And outside that, there is millions of websites, handcrafted websites and services that just no one knows about. Maybe you and I know about them, but people like my grandma don't know about that. They will never know about that because it's just trumped by Facebook and Twitter and just the huge platforms out there. So again, what does this mean exactly? That private companies own all data of all. Own a huge amount of private data of billions of people. We saw Facebook, 1.6 million people logging in every day. So I don't know about you, but to me this looks scary, that a CEO and maybe his few thousand employees have access to the whole 1/5 of the planet's everyday conversations, where they travel, what pictures they took, what they vote, what they will do tomorrow, like private conversations with their spouses, or stuff that people don't realize that they would never post on a public, let's say public paper here in the university. Would you post all your conversations with your girlfriend or your boyfriend here on a wall? No, but I think most people, especially those who are not in EuroBSDCon, I think do not realize that the extent to which this can go wrong, all this collection of information that can go wrong. If
I have nothing to hide.
Yes, I have nothing to hide. So okay, it's the same as saying I have nothing to say, so we shouldn't be able to speak freely, because I just have nothing to say. But I think people have something to hide. I don't think a friend of mine would just go post his private information outside his house. Oh, I'm going there tomorrow, please don't rob me, or something. I think, or post his bank account details publicly. I think it's just a product of people not really knowing their technologies, and the point of this talk is to, first of all, raise awareness about this and just inspire people to maybe talk with friends or whatever and explain to them that this is not really, oh, you just log in on Facebook and talk with someone. No. People collect all this information, and maybe what they do right now is just sell you more ads, because that's what they do most of the time. But if circumstances change, then maybe they will get you in jail if you say something wrong. Who knows in 10 years what this information will be used for? I don't know. In some countries it is already being used to target people on all sides of the spectrum, I think. I'm not trying to say one side is being targeted. One day you get a terrible dictator or something and they just jails everyone who said the specific word on Twitter. I think this is way, way too much power on unaccountable companies that weren't elected. And I think people use the argument that, okay, but you sign up to this, and yes, you do sign up to this, of course, but how many people really know the extent of this? I think my friends just went to create an account on Facebook and just made it. They didn't really have all this in their mind, that, oh, my information might be sold or sold for malicious reasons, and not just sell me noise and crap on the internet. But this leads me to my next point, which is that the internet in general, because all this time I'm focusing on social media. I just use this as an example because social media is the biggest thing people do on the internet, not really because I care too much about social media. But in general, the internet is very, very corporate nowadays. Everywhere you go, you will see 1 trillion ads. Even if you have an ad blocker, you will still see some ads. You go to YouTube, you watch a video, and every couple of seconds you have ads selling you crap that you're never going to buy, for example. Every interaction you have with the internet is just you trying to get information, but also get bombarded with ads and, in general, corporate interests. So I think that this really goes against how the internet used to be, that it was people sharing stuff. I have my website, I make articles about stuff I like. You make articles about stuff you like, we share them, we link to them, we talk about them. But nowadays it's just this plus please buy my product once you read this article. So I don't really like this. I think that's a big problem, and it changes people's perspective of how they see the internet. They just see it as a mall, I think, instead of a place to exchange information. So, not really related to to this, but I think this is, I know most people will say that this is completely unrelated to decentralization, which is the point of the talk. But I think, when I say uniformity, I mean that most websites, you saw in the beginning, this stuff. This is not uniform style, I think. Each style had its own, each website had its own style. People expressed themselves, they had their own character. And nowadays this is not really a thing. Okay, maybe some websites have some differences, but it's all guided towards marketing and what will get the most attention, and every button is placed exactly where it should be. Every color is precise, that will get you the more likes. And I think this has to do with centralization, because you want to get as many people as you want on your website and also keep them as long as you can on your website. So the style is informed by the fact that everything is centralized, I think. I don't know, maybe I'm wrong, but you can disagree on that later. So again, social media, I mention it all the time, just because it's everywhere. I think the amount of discourse and information going on social media is really uncompared to everything else people do. Again, normal people, not us, but normal people who just open their phone and just scroll social media. That's what most people do, so that's why I'm focusing too much on it. But I'm not really going to talk about social media, because very conveniently I have an article about this, which you can go read. This is not really about decentralizing or anything. This is just some research I did on what I think social media does to people and why I think it's terrible. So feel free to take a picture of it. By the way, the style of my website is also terrible, so. So yes, you can read it. I don't want to start reiterating and change the topic of the talk. This is not about why social media is terrible, which it is. So this article is for this. And so some solutions I want to propose to all this. Just quit. I don't have anything more to say. If you're using social media, go and delete it right now. I think this is the step one everyone should do.
It works.
Yes?
Yeah, it works.
Yes. Just delete it. I'm not talking about Mastodon, because people will get on me and say, oh, but Mastodon is so great. I know it's better. Use Mastodon. I'm not against it. I'm saying quit the regular, classic corporate, regular social media, Instagram, Facebook, all this. So this is number one. I think realistically most people won't do that. But I think if even one person from here does this, I think that's even enough service to humanity to do one good thing to get closer to removing so much power from all these big platforms. And I know what everyone will say, but how will I have networking effects? I don't have Facebook. Now how will I talk to people on the internet? I don't know. I think everyone older than 20 probably knows how this worked in the past. You can connect with people. In fact, it's not so hard. Here are a few ways you can connect with people without Facebook or social media in general. You can use web rings. Does anyone know what web rings is? Okay. Web rings, for those who don't know, is just pages that just link to other pages. That's it. Not very deep concept. RSS, I love RSS. I think I even use it to browse YouTube, for example. I never go to YouTube. You can use RSS. RSS is essentially a aggregated feed, your news feed, let's say, or your social media feed, but without social media. In the past, especially, every web page used to have this orange with an antenna symbol, which you used to click to it, and it gave you a feed of all the articles this website has.
Web pages still have them.
They do, but try to find it on YouTube.
Well, the problem is browsers don't have it.
Yes, browsers, well, they have add-ons, of course, but Twitter, for example, has it, YouTube has it, even GitHub has it, but it's very, very hidden. They make it hard for you to use it. It's not accessible to most people. It's just you get the link, you add it to your RSS reader, and every time there's a new post from that website, channel, whatever, you get a feed of that, and you can read it in the reader. Links pages, the same thing as web links, but links pages, I think, are more for your personal website. You have your website and you say, oh, these are cool websites you can visit, and you can go there. Mailing lists, some people like them, some don't. I think they're okay for some stuff. Development, I think all development of BSD is done with mailing lists. They work. Forums, not really a huge fan of them, but I think still it's a nice decentralized way to communicate. Decentralized, well, somewhat centralized, but better than having Reddit, which is all forums on planet Earth into one website. And now federated systems, ActivityPub, which includes Mastodon. Mastodon, right? It includes it? Yes, Mastodon. PeerTube, I think, is also on ActivityPub. Yes, all these great platforms. I love PeerTube, for example. Yes, and the talk is streamed on PeerTube, I think, which is great. And it does run on BSDs. XMPP for communications. Does IRC count as federated? Email, does it count as federated? Yes. Sorry?
It's closed federated, IRC is.
Yes. So all these platforms, you don't need to rely on someone providing you the service. Well, you can use the service. I don't host my own IRC server. I do host email server, but the point is you have the option to have it for you. Have your own kingdom on the internet and use it to communicate with people. But you can, of course, use, like Stefano does, the BSD Cafe. It's great. Go use it. But still, as he said yesterday, the point is not to get people on the platform and expand the platform, sell them trash, and just make money out of it. The point is to get people to go away from social media, and if they want, they can go host their own, which is, I think, the win out of all this. That's the profit. And then just use word of mouth. If you have a nice website, a nice channel, just tell it to people and they can know about it. So I think this is a non-exhaustive list of how you can interact with other people on the internet. You don't need a massive algorithm that comes with all the problems that algorithms have just to find friends. This is the GeoCities links page. I like it. So again, federated social media. Again, I'm going back to social media, even though I hate this topic at this point. But personally, I don't like them. I don't use Mastodon. I think my opinion is that the point is not to create clones of social media, just decentralized ones. I think the point is to go away from this model in general of the microblogging model, likes, dislikes. I think it doesn't promote quality content, although of course there is great content on Mastodon, and I've used it multiple times for resources. But I think the ideal world for me would be that everyone has their own website, be it blog, be it, God forbid, a WordPress website. But I think this would be the ideal world for me. That doesn't mean there's no place for social media, that if you, Mastodon, federated social media, that if you use it, you're a terrible person. No. If you use it, if you really are lazy or you just like social media and you really want to use it, yes, 100% go use federated ones. If that will make you go away from the centralized ones, yeah, definitely go use it and never make a website. But I think that's still profit. But personally, I won't endorse them. That's what I want to say. That doesn't mean I hate them or anything. I just don't think it's the right model. but there is place for them. So, yes. Yes, I think I came to the wrong conference because I haven't even mentioned BSD at all for lots of time, and I'm running out soon. So what I would like people to do, including me, is instead of, apart from self-hosting, obviously, I think BSD Cafe is hosted on BSD. I know tons of services who are hosted on BSD, even the centralized ones, unfortunately. But I think a great way to fix this would be for people to start making tools running on BSDs, because they're, in my opinion, and I think in everyone's opinion here, a bit better, right? They're more stable, they're more secure, they're easier to work with, and I think they just serve a great foundation for tools to be built on. So why BSD? Just because of what I said. They're stable, they have security, they're very efficient, all of them. I'm not focusing on one particular flavor this time. So FreeBSD, for example, has jails, has ZFS, has Beehive, which are great for very large systems, especially ZFS. Large systems where you have maybe a service, for example, and you want to have, or a server that you want to have multiple instances of something, multiple different services, that's great. You can have PF, great, firewall. SMTPD, I don't know how many people use it or know about it, is OpenBSD's server, mail server. Great software, I think. Just like the one below it, HTTPD, which is the web server of OpenBSD. This is what I use personally. I love it, it's simple to configure, nothing more to say. And I have ... for the ones you think are equally good. I think because all these things come out of the box, I think that's just a good platform of choice instead of installing Windows or Linux and just having to fight with the system to get something working. And the reason I don't promote one BSD is because they're just good for different purposes. As I said, FreeBSD is good on its own for some things. OpenBSD is good for other things. NetBSD is good for other things. I don't want to just promote one thing only. I think there's place for all of them. And they're simple to use. So how do you start? How can you go? How can you make a favor to humanity? Well, buy a domain name. That you can buy a domain name for 50 cents a year, maybe. I think
it's centralized.
It's centralized. Well, okay, we can accept this kind of central. I guess we can swallow this one. And yeah, domain name, you can find it. Most of them are cheap as long as you don't have some very 3-letter domain name or anything. You can find, I think everyone can have €1 a year to spend on a domain name. And then a server. So I'm not going to explain what a server is. I think we all know that. You can either rent a VPS, which is someone else's computer, most of the time. For example, I rent a VPS because I don't want to spend too much money on electricity. Or you can self-host, which is just have this computer running your service. VPS, again, you can rent a basic one for €4 a month. €4, I guess. If you started searching on the road, you would find €4 at some point. So very affordable. I don't think there's any excuse nowadays that starting your own service is expensive or it's hard. There is a learning curve, but it's not hard, and it's definitely not expensive, I think.
You can self-host on your e-cigarette nowadays.
Yes.
Just don't throw away.
So what is my setup? It's very simple, nothing special about it. I just rent a VPS. The cheapest plan I think I found. It runs OpenBSD. I run a web server, an email server, and a Git server. And then just some FTP server and some internal stuff. But the web server, I just use the HTTPD server. I will show you how simple the config is. It fits in one screen. Not the config, how to get from 0 to having a website, I mean. Email server, I will admit this is a bit complicated. Otherwise, we wouldn't have a 7-hour tutorial the previous days. But I think it's worth having, although a bit annoying with spam, and if you don't know what you're doing, I think it can be a bit pain. So that's why you could use IRC. XMPP, whatever. And Git server, just normal Git server, nothing fancy. So this, assuming you have a domain name, of course, and it's connected to your server, from start to finish, this is how you get a website on OpenBSD. That's it. You're done. You can now post HTML with SCP or something to your server, and that's it. You have a website. Public, everyone can see it, everyone can link to it, that's it. Nothing complex. So this, you just need, this you can even ignore if you don't want HTTPS. So you can even start from here with your website. That's it. I think most people have used Nginx here. I don't really like it. I think it's a bit complicated, at least for my needs. So I think anyone who's a slightly technologically literate doesn't have an excuse that they cannot make a website. I think it's way too simple. So some ideas I want to propose for decentralizing the internet is your online presence, it can be just a website. I think most of you have websites here, so we can take this out of the, I don't know how to say it. So yeah, have your own website. Video sharing, you can still have it on your own website, but I think PeerTube is great. It's peer-to-peer, so you can save on bandwidth. And it's also federated, so people from other instances can comment on you. It's just a nice YouTube alternative. It's better, I would say, even. Communication, again, IRC, XMPP, email, whatever. Have your own Git server. Not really necessary, because I think there are good enough services out there. Open source services for, like SourceCat, for example. There are good services, I think, that you can rely on. But if you really want to be as decentralized as possible, you can even have your own Git server and not worry about anything. So, okay, all this is great, but there are a few, one problem, really, that it costs time. I said before, so I lied a bit. I said that it's very simple. You just have, 10 lines and you just have a website now, that's it. Okay, it's not as simple. You need to maintain the server. If you want to do more complex stuff than just have a web page, you need to maintain the page, you need to update the servers, you need to maybe extend it if you want to. So if you want to have services, for example, that is a bit complicated. It cannot be done by my friends or my grandma, right? So I think complete decentralization is probably not possible because of some learning curve there is, even nowadays. But I think for most people, at least here, I think just making your own existence is not really hard and not going to cost too much time. Well, if you want to host Mastodon, I think you need some money. It's not free with all this data that you need to store. And okay, great idea. So as I said, that's not for everyone. I think, how many users of the internet are there nowadays? 1, 2, 3 billion? I don't know. Okay, not all of them are going to have decentralized existence and use all these nice services, PeerTube. No, my grandma probably will never use PeerTube in her life, probably. Or will never have her own website. But I think that, okay, I saw it. Okay, but that doesn't mean that, because the majority of people will still have to, even if the internet gets more decentralized, normal people will still have to rely on my service. And so you could say we can never be completely decentralized. Everyone really is independent on the internet. No, people will still use someone's service, but I think 10 services controlled by real people is better than one service which controls the whole planet. I think it's not really about being absolute and, we're going to fix the internet for good. I think that's a bit unrealistic. For me, even if half the people from here do something for that, I think that's already good enough. And maybe in 10, 15 years, I don't know what the internet's going to look like, but maybe everyone will be using more federated, decentralized solutions. And this is really just a real challenge, as I said, that it's easy for us to do all that, but I think it's hard to make this mainstream or remake this mainstream, right? In the past, maybe it was mainstream and everyone had their own websites and everything because the internet was used by technical people. It wasn't used by everyone from the age of 5, right? So people knew what they're doing, it was easier for the 100,000 people who use the internet to make websites, share information, do all this cool stuff. But I think this is a lost battle. That's what I want to say. It's we have to accept a level of centralization, but at least a less serious one, a less scary one. And the conclusion is, I should have this slide a bit before because that was my conclusion. But plus that it's quite easy to start, at least, with BSDs. Linux, I really haven't played around with it. Maybe it's even easier. I don't know. But I think BSDs, you can just install OpenBSD on your laptop, write 10 lines of config files, and run a few commands, and you have a website. Then as long as you can write Markdown or HTML, that's it. You don't really need anything more. You can communicate with the world. People can read your articles or see your cat photos or whatever you feel is important to share. So, thank you. Questions? Oh, whoa, whoa, too many. Sorry, the microphone is here. I can give it anyway. Thank you.
How much do you think, you haven't talked about search engines. Like, it strikes me that's a big kind of single entry point.
You know what? Sorry to interrupt you.
Okay.
I have notes here that I never read eventually. But I have a whole paragraph on search engines that I just missed. So yes, search engines, huge problem, yes.
Yeah. I guess my question is, how much do you think, something like Google, like I literally, like, I see, people that are less proficient with computers, that the internet is Google. Like, you know
yes.
what I mean? Like that search box.
Yes.
It controls so much and it shapes so much of what you can discover, of what is presented to you.
Yeah.
Right?
Yeah.
What do you think?
I think there are already services like Circs, I think, which are decentralized. You can just host your own instance of it, and you can choose which search engines it uses as a backend. So, yes, huge problem. And also the problem with these search engines is that they use lots of AI slop nowadays. So even if you could find those websites that I'm talking about, you'll never find them, because until the 5th page maybe, it's all full of AI crap, and Reddit and Facebook posts. So yes, yeah, I just forgot to mention it, but I do have the note here. So thank you for mentioning. Next.
The next one was here. Do you run your own DNS server?
No, but I should. No, actually, I'm a bit of a hypocrite from what I'm saying, because as I said, I use a VPS for that. But I'm trying to move to self-hosting. I just want to find a cheap solution to do that, and not have servers running in my house all day. But yes, no, I don't have. But I would like to. Next.
Thank you. That was really interesting talk.
Thank you.
My mum is in her mid-70s and she uses WordPress just fine. I think you're a bit dismissive of WordPress, but it is a decentralized website.
Yes.
It's something that
it can be.
It is decentralized. She's not on WordPress.com. It's hosted on
her
own domain name. But when I looked at your Nginx config, why isn't there a GUI for that? Why isn't there something nice and simple rather than having to dive into V or Emacs or whatever to hand configure it? It seems like quite a lot of this stuff, we talk about re-decentralization and say, why is no one using it? It's because the tools are crap. They're not as easy to use. WordPress is really easy to use for anyone, and it's, that's why it powers 40% of the...
I agree 100%. That's why I mentioned at some point, at some slide, that the goal is to just make user-friendly tools. User-friendly meaning normal people-friendly tools. Something that my sister can install and she will have a website magically. Just install this on a server somehow. I mean, we can talk about how this can be done, but yes, of course, I agree that editing config files, probably not for everyone. Not probably, definitely not for everyone. The only reason I picked on WordPress is just because I had to fight with it multiple times and I hate it. But apart from that, yes, if that will make you go away from Facebook, yes, use WordPress. I'm fine with that.
And you can add federation to WordPress.
Yes.
You can comment on WordPress and this will be
Okay, nice. I didn't know about that. Nice. Next.
No, I just wanted to say about easy to use web hosting tools or decentralized tools that we were close to that for a moment. I remember that at the beginning of the millennia, Microsoft and Apple started to propose home server solutions which anyone could install with relative ease. But then cloud diverged from this.
Yeah.
So it's not so utopian. We were already close to that.
Yeah, even better then.
So I would like you to think about semi-federated or semi-decentralized approach, because if I speak about my friend and his band, he really liked the, oh my God, Tom's social network, what was it called?
MySpace?
MySpace, yeah. The thing that bands like on it is that
yes.
you can create your own page, your own look, your own style. And because they cannot host themselves, maybe something semi-decentralized is the way. I don't know, but think about it.
Again, I brought it up at the end. I don't think 100% decentralization is possible. I think that's a dream, mostly. But yes. Sorry, next? Oh, too many questions. I didn't expect that.
I have rather a comment, not a question maybe, but besides all of the technical stuff, from my personal experience, the hardest part in this situation was to convince my friends, relatives, to actually use what I can provide. And let's say, the most recent example that when YouTube started, let's say, Russian government started slowing down YouTube, it appeared that VPN server I'm running is actually needed. So for me, it was the hardest part.
I agree 100%. I don't have anything to add. Yes, I think, yes. It's hard to take people out of the things they're used to using for the past 10 years, maybe.
Not a question, rather a comment, and returning to the WordPress topic, because actually WordPress is a tool that is pretty close to the vision of Tim Berners-Lee. Because originally in Tim's vision, he wanted the people that run the websites to also be able to publish, right? So WordPress is actually implementing this part of the HTTP protocol, because we always forget that apart from get and post, we also have put and delete and so on. So this is like the forgotten part, the technical one. And WordPress, being it as it is still helpful in this aspect, because it empowers a lot of people to publish online.
Yeah.
And as you said, that it's possible to do it on your own, and at the same time on WordPress.com, whatever.
So is there a debloated version of WordPress out there?
There are some.
Yes? Okay, so that's great.
And and one more thing. There are things that are more important and less important. We still are in RSS. I mean, RSS is still around, but the problem is it's not visible.
Yes.
And this is one thing that I would dare to say, that we have been betrayed in this aspect, even by those that claim it to be open and struggling for free internet.
Yeah. I agree. Any more questions? No, I'm already past the time, so you have to. But thank you for coming.
Good late afternoon, everyone. So my name is Hiroki Sato, and I'm going to talk about the USB Type-C support on BSD. So let me introduce myself first. I am a FreeBSD committer since 2000 and working in various areas, including the USB things for some time. It is 2 years. And I want to have a talk about the USB Type-C, but so this is outline of my talk. And probably you wonder so why I have a talk about the USB Type-C, because probably you are thinking that the USB Type-C is just a different form factor for the USB Type-A, and probably you are already using a Type-A and a Type-C with your laptop and without any problems. And probably you do not have any questions about the function. But I gave a talk about the USB debugging capability 2 years ago at the EuroBSDCon in 2024, and BSDCon. USB DBC here, the debugging capability is one of the feature, hidden feature in XHCI host controller, and useful for the kernel development debugging. But during the development of USB DBC, so I will explain the details later, but in short, there is a way to connect the two USB hosts to laptops using the A2A cable, and you can get the CBL console access. So this feature is pretty useful for kernel debugging. And my device driver works with the USB-A port, but I could not get it work with the Type-C port laptops. And I had no idea why the Type-A works and Type-C didn't at the time. But after investigating the difference between the Type-A and the Type-C, I eventually found how to get it work, but it was a bit complicated than I thought. So that is why I decided to have a talk about the USB-C, and I want to share the experience on developing the device drivers and what we want to have in the BSD operating system, and what we currently have and what currently do not have. So after the debug capability thing, I will explain the software components and hardware that are involved in the USB Type-C ports in your laptop or desktop machines. And if we have a device driver, something additional things you will get. So I will explain the details of the device driver stuff and what will be the benefit. And of course, I'm working on the device driver still, and I will share the work in progress. And currently, I'm working on the FreeBSD device driver, but I want to make it portable across the BSD operating system, including the debugging capability driver. Okay, so let me explain the background. The first thing is, I do not think I need to explain the USB Type-C or Type-A things in detail, but let me explain the technical things you have to understand to listen to my talk in a later slide. So please give me time for explaining the basic technical thing first, and then I will talk a bit about the debugging capability. So the thing is, you are familiar with the Type-A, and Type-A has two versions. One is the USB 2.0, and another is USB 3 version. The difference is number of pins and the number of wires. And the most basic one, so USB 2.0 has only 4 wires, and 2 are signaling, and another 2 are power supply. So there are only 2 wires, D plus and D minus. There is no concept of the data transfer direction. So you can put the voltage swing using the 2 wire at once. So there is no distinction between the which is sender. So you have to have some protocol that supports the half duplex communication. And it is mainly used for the small gadget like keyboard or USB mouse. And it is inherently very slow throughput, very narrow bandwidth it can be supported. So USB 3.0 or 3.1 and 3.2, the version number is very confusing because the USB specification is, the name is changing year by year. But you can understand that all of them as a USB 3 or 3 something. And this specification has a different form factor, but the upper compatible with 2.0, and the 4 pins are still in the same place, and 5 additional wires are added. So 5 additional wires means the ground level and the signal. So receiving signal and sending signal. So RX and TX means transfer and receivers. So these two set of wires are used for the super speed transfer. It is a specification of USB 3.0, and you will get the more higher speed transfer using the additional wire. And still, D plus and D minus is there in the same place, so you can use the older hardware that does not require higher speed transfer like a keyboard and mouse using the same port. And you can see that this kind of port in blue color in your laptop and the desktop. Okay. And there are several variants of the USB connector. And this is a micro B, and there is a B or something. But probably you can see the micro B before emerging the Type C. This is popular to connect the small gadgets like a USB mouse. And the right-hand side, micro B super speed is used for the portable hard drive. But the basic concept is almost the same. So micro B has 5 pins, and super speed has additional 5 pins in a different way. But so just the difference in the physical form factor between the Type A and the B. And there is no difference from the software perspective. But in Type C, this is the cross-section of the Type C connector. Type C, so in a specification, USB 3.3 and 2 and later, Type C connector is adopted. And this single connector has 24 pins. But the upper side and the bottom side has 12 pins each, but completely the same set of the pins are located the upper side and the bottom side. So substantially 12 pins are used for communication over the USB cable. And the reason why the upper side and the bottom side are used for the 24 pins is you can flip the connector. And 12 pin means the 3 more pins compared to the USB 3.x. And that means the 3 additional pins are here, CC1 and SBU1 and the VBus. VBus is already, another pin is available in all the 3.x specification using the type A. So the difference is the CC1 and SB1. And in 24 pins, the upper side is something 1, and the lower side is something 2. So the CC1 and the CC2 is located, so the A5 here and the B5 here. So these two are supposed to be the same function, the same meaning, if you flip the connector. But these two are a major difference in the physical connector. So this CC and the SBU additional pins. So this slide shows the one thing that that is related to the how to use the CC wire. So the data transfer over USB protocol is performed using the existing the RX1 and the TX1 or wires prepared for the USB 3.1 and 3.0 in the Type A equivalent. But in the Type C, these additional pins are used in various ways. And one obvious way to use the CC line is the host and the USB device can detect which direction, which orientation of the plug is used when you insert the cable. So the cable is a bit special for the Type C. Actually, 24 pins are not, all of the pins are not connected to wire in a cable. CC1 and CC2, there is 2 CC line, but the normal USB-C cable has only 1 wire. So CC1 or CC2. The specification says the CC1 has the wire, and the CC2 do not have a wire. So this is USB host in the laptop, and this side is USB device like a USB mouse. And if you connect these two, so host and device, using USB-C to USB-C cable, only one CC is connected because the CC1 has wire and the CC2 does not have wire. So in this way, both sides can detect which orientation is used when inserting the plug. If you flip the one side, the wire will be connected in a different way, so CC1 to CC2, because the CC1 and the CC2 location is symmetrical. So if you flip the connector, and the CC1 wire will be connected to the CC2 pin on the other side of the device. So detecting that this connection, the USB port can recognize which direction is used. However, this symmetrical nature allows so even if the detection is failed, the signal will be delivered using the two set of pins and the wires. But this is one of the simple example where the CC line is used. So after the Type C connector is introduced, a lot of useful features are implemented as an extension of this port. So CC line is overloaded with a lot of features. One primary usage was the USB PD support. USB PD is you can get more voltage and more current from the chargers like this one. But negotiation is required between the USB charger and your laptop or your USB device. To do that, the communication is performed using this CC line. So the charger can advertise that I have 5 volts and 9 volts and 20 volts available for the USB host, and your laptop will reply back to the charger, so I can accept what voltage. And the negotiation is established. The power is supplied from the charger. This message exchange is all done over the CC line. And this is one of the examples of the ESP PD message. It is a simple serial framing. So first, the connector is established the physical link. The PD message will be sent from the device and from the host and exchange the information. And various information can be exchanged. But originally, this is designed for the ESP PD only, but currently, there are a lot of functions are overloaded in this frame. So you can identify the partner, so the device on the other hand, and to negotiate the capabilities not limited to the PD. And this message is used to control the USB Type-C port itself. Okay, so one of the interesting feature of the Type-C is the DisplayPort auto mode. If you have a laptop and the laptop has 2 or more Type-C ports, but no HDMI output and DisplayPort output, but you want to have a connection to the external display. In that case, the laptop manufacturer can utilize the Type-C port to deliver the DisplayPort output directly on the USB Type-C pins. So this is not tunneling over the USB protocol. It is totally different totally independent of the USB function. The port function for the USB, so RX or TX, these pin assignments is designed for USB, but this DisplayPort auto mode changes everything dynamically. So TX1, TX2, the RX1, RX2, the 8 pins are available in the USB-C port for USB. But if the DisplayPort auto mode is enabled, some of the pins are connected to the output of the GPU directly. So it is totally unrelated to the USB controller anymore. So the directly a DisplayPort signal appears on this wire. And SB1, SB2 is also converted to the connection or the communication channel for the sub-side communication required for the display port. And importantly, to switch the mode, you can send PD message to this port. So probably you have the conversion cable that converts the USB-C to HDMI or USB-C to DisplayPort, or maybe you have a USB dock that have HDMI and a USB port and a lot of ports on the device, and you can connect the single USB-C connector to your laptop. That kind of device will send the USB PD message. It is called a vendor-defined message to connected port first upon the connection. This USB-C port will receive that message, and configuration will be dynamically changed. If you have a HDMI port on your dongle or USB dock, some of the pins are converted to the DisplayPort connection inside your laptop. So you can choose any of the Type-C port on your laptop, and any port can support this kind of routing. So that is thing is totally different from the Type A. So 3 additional pins are obvious difference, but this kind of configuration and the PD message is a unique feature for Type-C port. Okay, this is a summary what I taught so far. So CC pins for designed to detect the port orientation, but for PD, the PD messages can be delivered over CC pin. But nowadays, the PD messages have a lot of feature not related to PD. And so, of course, power delivery capability is one of the major purpose. But the pin assignment can be dynamically changed. And even for non-USB protocols are supported on the Type-C port, especially from the USB 4 specification. Okay, the basic thing is finished, and let me move on to the USB debug capability. I gave a talk in 2 years ago. So USB debug capability was the feature I wanted to implement because I have trouble in the kernel development on a laptop. It is difficult to get to the serial console when I have panic and I cannot access the crash dump or something like that. And I try to use the small PC that have this legacy serial port and to get the serial console for some time. But when I investigate the USB functions from the specification document, there is a USB debug capability, and it is it is optional feature in the specification, but almost every actual implementation has a capability in a chip level. This is the hardware level support. It does not require any software. So if you have a device driver that can access the register and just enable it, everything will be handled in a controller chip. So writing in the device driver is not so difficult, so now I try to implement that, and the result was presented 2 years ago. But so the function is just like this, and the goal is to establish the serial connection using the USB cable. And usually, USB specification doesn't allow the connection between the USB host to host or USB device or the device to the USB device. So always the topology of USB is something like this. The host root hub is your laptop, and your laptop is operate in the USB host mode, and the USB host mode can accept the connection from the USB device, not accepting a connection from the USB host. So the topology will modify the star, the tree-like topology, but the host must not be connected to host. But what I want to do is connection between the USB host to realize the serial communication between the two machines. So to overcome this limitation, USB debug capability will do some special operations in the USB A port on the USB host device. Specifically, this sentence explains that this feature will flip the wall on the USB host ports to USB device. So only one port will be converted to the USB device, and from other USB host, this port can be seen as a serial device. So I mean, so in a sense of the legacy serial port. So from the host, the upper side, so this port will be recognized as a serial port. And on the target device, operating system can feed the data to be sent over the serial connection. Just put the data on the specific location of the memory. It is the controller chip will fetch the contents or by using the DMA, and always do not need to support from the operating system. Just putting the data you want to send on the specific location, and data coming from the USB host can be received just reading the specific memory, the specific location of memory. So this worked, but this requires the A2A cable. I don't think it is popular, but the specification says the A2A is in a specification. So you can find the A2A cable. It is compliant with the ESP 3.1 in the market, actually. At least in Japan, I can find one cable. And this cable is, has a special connection between the two plugs, and the A2A is always a cross cable. This is in a sense of legacy cross cable for the serial console cable, new modem cable. But this is not a violation of the specification, and it's available in the market. And I bought one, and I think in Europe and in US, this is sold as a debugging cable for Type A. And that is working, but when I try my device driver on the modern hardware that with the Type C only, or Type A and Type C, it didn't work. And I had no idea why. So why the device driver didn't work, because I could, the DBC, so debugging capability, enabled on the controller level. And the controller status replies to the query that's saying the debugging capability is now working, but no data is appeared on the cable, and the debugging cable is not recognized by the controller. And at the time, so 2 years ago and 3 years ago, I thought Type A and Type C is just a difference between the physical form factor, and using the A to C converter and the C to C cable, or so conversion cable works as even if the host and device has a Type C port. Of course, A to A cable is special, so I bought the two A to C converter and A to A connector, A to A cable, plus the two of the converter. I can connect the two hosts using Type C to Type A to Type A to Type C, and the series of connection. But even after that, the XACI controller does not recognize a debugging cable. So eventually I found why this is not work at the time, but I did not have any insight for 1 month or 2 months. So that is the motivation why I want to make a presentation about the Type C ports. It is not just different physical form factor. So let me explain the controllers and the software associated with the Type-C ports. So you have to aware of if you want to know the technical internal of the operating system and the firmware on the laptop. So in the technical aspects, the Type A port is almost directly connected to the XHCI controller. This is Intel controller interface specification, and it's pretty popular. And USB 3 point something or the 4 point something, all of them are currently we are using the XHCI. For the USB 2.0 or USB 1.1, the UHCI or EHCI or something, there are a lot of something HCI, but after the USB 3, XHCI is consistent name for the controller. And all of the BSD flavors, including free and net or open, have an XHCI device driver. And this is supposed to be on the PCI device. So operating system access this controller via PCI register space. And configure and the ports, and you can detect the connection, and you can control the connected device using this single device driver. And strictly speaking, the layer 1, so physical layer, there is a PHY between the controller and the Type A physical port, but it is not related to software. So from the signaling perspective, the controller is directly connected to the Type A port. It is simple, and that's what we have now. But for USB-C, the situation is totally different. That is things I didn't notice 2 years ago. Yeah, XHCI is still here, and the OS can access here. And XHCI controller is connected to Type-C port in some way, but the two controllers are located intermediate between the controller and Type-C. And the Type-C port is shared with the non-USB devices like GPU for the DP auto mode, and the Thunderbolt controller share the same physical media. So these two additional components are essential for the Type-C port. And the first one, Type-C port controller, it is called a TCPC. This is responsible for communication over CC pin and control the ports in terms of the USB PD support or changing the pin assignment and for the DP auto mode or Thunderbolt support. So this controller will be responsible for the communication. Then the communication over CC does not use the XHCI controller at all. So USB PD message exchange is not related to the USB protocol. That is independent protocol named the USB PD. So XCI is independent from that. And another confusing point is there is a multiplexer here. This is a simple switch, just switching from the USB controller and GPU output, because the pin output can have totally different signal. And sometimes the USB output is output bit here, and sometimes the display output is routed from here to here, independently from USB controller. To realize this routing, the multiplexer is here. And multiplexer is not a part of the Type-C port controller. Type-C port controller are responsible for only one port, and switches located differently. So currently, all of the BSD flavors have no driver for these two parts. However, we can enjoy the Type-C devices. Probably you can already use a Type-C device without any problem. Because what? Because a Type-C port controller can work without operating system. So this receives the CC message from your device and change the role of the pin automatically. So in most cases, in typical cases, you do not need to care about what kind of message is exchanged. However, some corner cases, you have to control these two controllers. So that is the problem I encounter for the USB debug capability. But the modern OSs, including the Windows and the Mac OS and Linux, have already device driver for them. So it is sad for the BSD operating system to have no driver. So I started to work on the writing the device driver for them. So that is a big difference. So to enable the USB debug capability, these 3 steps are required. That is things I didn't notice. First thing is USB Type-C port must have special cable. I thought that I can control these 2 parts. I can use the normal C2C cable, but it was not true. Because the Type-C port controller denies to accept the normal C2C cable, even if the signal routing is set up. So this controller will report that this is not the debug cable, and the XHCI controller will deny enabling the debug capability. So there is no way to overcome this limitation. So we need to, I needed to prepare the decent debug cable for C2C cable. And I now realize that what kind of cable is required. And in addition to that, this multiplexer must be controlled independently from the Type-C port controller. Even if Type-C port controller recognizes the debugging cable and that is reported back to the XCI controller, this switch is not always to be correct to point this signal path. And you cannot know without accessing this switch. And this controller does not know the existence of the multiplexer, and the USB XCI controller does not know the existence of these controllers. So sometimes this routing is not initialized, and especially debugging capability is not the typical usage. So this is manually configured to secure the connection between the XHCI and the USB-C connector. And then the XCI controller's DVC capability is enabled, just like I wrote the device driver for the Type A ports. So this is worked, but these 2 are was missing. That was why the DVC was not working. But the special Type-C cable is a missing part. And I revisited the specification, and this is a slide in the previous slide that explains the role of the CC. And it is used to detect the flipping of the cable. But for debugging, you need the special cable that both CCs are connected. This kind of cables are not available in the market. I tried to find this cable, but I could not find anything for so I tried to find for 3 months, 4 months. But only an Intel development board accessory have this cable. But I could not have the access to such a cable because it requires registration and it is not for public. So they have debug accessory mode cable. And this word is appeared actually in the specification, but in a pin assigned the cable wiring is CC1 and the CC2. Both line is connected. And you cannot use this kind of special cable for normal usage because if you have two lines, the both side will not detect the cable because it is normal. It is an abnormal operation. So if you have only one line, you can use that CC cable for connect the device and the host. But if these two lines, it is dedicated for the debug only. So when this kind of this sort of cable is connected, Type-C port controller reports the debug cable is connected to the USB controller. So that is a prerequisite for enabling the debugging capability. So what the OS must handle to establish this kind of flexibility, we must have a driver for the switch, the multiplexer, and we must have a Type-C port controller. In most cases, these two controllers can be ignored from the operating system. The operating system do not need to take care of the existence or status of these controllers. But if we have these two drivers, we will have the more flexibility. For example, signal tunneling can be done, especially for the DP DisplayPort auto mode and the Thunderbolt tunneling. These two functions can be activated using controlling these two components. Of course, you can plug into the USB-C port. So, for example, you can have SSD enclosure that supports the Thunderbolt support. That device will send PD message to the Type-C port controller. I want to have a Thunderbolt connection. And this signal will be transferred to TV controller here. And routing is established automatically. So even if we do not have a driver for operating system, typical usage will be covered in the hardware level. However, we can have a driver to control to get more flexibility. And you can change the display auto mode on and off without any inserting or plugging out the device. And sending a PD message is possible if we have a TCP/C driver. So you can use your laptop as a power bank or opposite direction from the OS level. So these two components are required, and these are just the interface to the driver. So, and independently from the Type-C port and the USB controller. So in the OS, a single Type-C port has a lot of features and a lot of status. So a kind of state machine is maintained inside the kernel for the consistency across the controllers. So these three components are things I am working on right now. And for standards interfaces that Windows and macOS and Linux are using, and mainly these standards are developed by Intel. But for multiplexer, there is no standard. But for Type-C controller, there are two standards already. And the TCP/CI is a consistent interface to USB PD controller. And the UCSI is a more system software friendly, higher level interface that uses the firmware or embedded controller of your laptop to manage the Type-C port. So this interface can do the more higher level, and this interface will do that you can change the voltage or current in a specific value or a very fine-grained control. And UCSI is becoming popular, and probably you can find this device from your ACPI table when using BSD or BSD and the ACPI dump is used. So these three drivers is I'm working on, and I implemented a part of the driver to experiment so that I can get the debugging capability working with this Type-C port, but I feel I need to rewrite more consistent way to, as well as systematic way to support the whole thing in a cleaner way in the kernel. So I'm working on that. Okay, this is the summary for the talk. And yes, you are already using the Type-C ports, but in the OS level, there are things we do not have currently, and if we have, it gives more advantage. And especially for the USB debugging, I need this driver, so I'm working on it. Okay, that's all. Thank you. Okay, any questions?
We have questions, Mike. Yes. Well, we do. In principle, we do have a mic, but it doesn't actually mic.
No, it's on. It's going to the stream.
Oh, it's going to the stream. That's great.
For everybody watching at home.
Oh, that's great. So, a question: how does USB 3 interact with USB 4?
So USB 4 is a combination of the higher speed bandwidth support for the XACI and the tunneling support for Thunderbolt-like protocol. So there is no difference, substantially no difference from the USB 3.2 for the USB function. Just a standardized way to support the Thunderbolt part and the auto mode things overloaded on the Type-C port. The Type-C port is mandatory for the USB 4.
Yeah, thank you.
Okay. Okay, thank you.
Is it good? Okay. Sounds good. All right, welcome everyone. This is Sandbox Your Program using FreeBSD's Capsicum. I'm Jake, and let's get on with the presentation and start with a little bit about me. I am a FreeBSD source committer where I primarily focus on Linux compatibility. So I've dealt with Linux KPI, graphics drivers in particular, a little bit of timer FD, signal FD, but I want to make it as easy as possible to use Linux software on FreeBSD to ease the transition for new people into the operating system. When I first made this talk, which wasn't even that long ago, I worked for a company called Nixon out of New Jersey, and they maintained 100 gigabits per second networking stack with custom hardware. So I was the driver designer and developer for that. But now I work at Netflix on low-level automation and tooling, particularly focusing on OpenBMC and high-throughput traffic generation. Okay, so let's dive right into it. First thing I want to note here, and I kind of put this in the preface for the talk, is that the number of CVEs that are occurring each year has been rising. And it actually looks like that trend might be broken this year, but as you can see historically, right, it's been trending upwards, meaning that software is, I don't want to say less and less secure, but more and more vulnerabilities are being found in existing software. And well, what do we have, like 2 months left? So I don't know, maybe we can make up that little bit and, I mean, hopefully not, but continue the trend. So with that, and with IBM's cost of the data breach, which shows that an average cost of a data breach is around 5 million, which is up 10% over the previous year, it's kind of important to prioritize security in your general development workflow. Okay, so let's start off with an example program that might outline a use case for Capsicum, or I guess security models in general. So this is a program, a relay program, that essentially interacts or acts as a mediator or a middleman between consumers and then a device, right? And devices on that side. And the way that the communication happens is over a node in DevFS, right? So you just access this node, send whatever you want through it. It goes to the relay program and then back to the consumer. And you know, it's a multi-communication duplex, full duplex. So based on the program's responsibilities and it being a relay that assuming these consumers can spawn in and out at any time, this probably needs to be running at all times, which means that it needs to be a daemon. And an attack on a daemon is, I mean, it depends on the context and what's running in the daemon, but it can potentially be more insecure since it's running all of the time, right? As opposed to a program that might just run for less than a second, per se. So that introduces some important security concerns, and people have started acknowledging this inside of the FreeBSD project and capsicumizing or sandboxing the daemons that come with FreeBSD base. And if you're running a daemon, especially a system daemon, it is going to probably be run as the root user, which increases the stakes, I guess, when someone attacks your program. If they get access to the program, then they essentially have root access to your computer, assuming it's not sandboxed. And they can get arbitrary code execution. So, kind of expanding on this a little bit, the easiest security model, which is what most people end up going with, unfortunately, is to just run your daemon as the root user, and this gives it all of the necessary resources it needs to properly function. And if an exploit is found, then, like I mentioned earlier, if it leads to arbitrary code execution, then they can just run commands as the root user. An example of this might be, say, some kind of buffer overflow happens and you're able to get that arbitrary code execution. They could potentially run like the rm, rf, /, right, and which would not be good. And that would be allowed as the root user. So here are some solutions to fixing this kind of problem, or maybe fixing is the wrong word, but minimizing it, right? So POSIX 1003.1e capabilities are something that exist purely in Linux right now, and they essentially split up root privileges into a bunch of different sub-privileges or different categories. And the idea is that you give a single process only what it needs for it to do its job. So I have an example here for capkill. Say you just want your process to be able to send signals to other processes that are not of the same user that started the process. Then you can give it capkill, and then it can bypass the permission checks for sending signals. And there are a number of different capabilities that Linux offers, over 20 for sure. But I put this kind of picture here to demonstrate or give an analogy of what this is like. Say you have your initial process state as like a key ring with one key, right? You have access to one door, okay? Giving it POSIX capabilities is essentially like adding 2 extra keys or however many capabilities you give to your program. It's adding that many keys for that amount of capabilities. So you're essentially extending your key ring, right? But as you extend your key ring, you're also introducing the possibility of 1003.1e capabilities. Let's go back to the diagram here. We start with a full, usually run your pledge program as root. So you have all of your accesses, privileges. So yeah, I kind of went over that already. Now, Capsicum is a completely different approach because you're essentially putting yourself in this sandbox where you're not giving any extra privileges or you're not reducing any privileges. You're effectively just putting a box around yourself with the current state that you're in when you enter capability mode, right? So an example here, and let's go back to like the analogies, right? Say you live in a community and you're this person. You can interact with these people freely. You can go and steal something from this person. You can go and, stab this person, right? You can do whatever bad things you want to. But when you put yourself or your process, right, into a Capsicum security sandbox or capability mode, you're essentially putting a wall around yourself, and an indestructible wall. So you can't attack these people, you can't steal from them, you can't do whatever it is that you'd want to do to get sensitive information from someone else. And this also has the advantage that, other people can't access you as well. Okay, so now that we have our options in line, let's go to our example process and apply them. So before we do that, we need to first understand exactly what our example process is going to do, right? So here's kind of a breakdown of the different calls that we're going to need and the different functionality. So we have our consumer. We need write access to a Unix socket. We need to read from the relay program somehow. And then we need to perform IOCTLs on the devfs node. Right, so a number of things that need to be done. And these are very common inter-process communication or just general read and write mechanisms in Unix-based systems. So once it sends your device processes a message and it sends a response, your program is going to take different actions, right? So the previous example was one way, right? It was going to the device. The device also needs to send a response back, which includes another IOCTL, write to Unix socket, potentially write to shared memory, and then your consumer reads from the Unix socket or shared memory. Oh, and I also forgot the signal. Right, so a number of things going on here just to try to make it as complicated as possible. Based on those responsibilities, here's kind of the list of things that I just went over. So you can read and have it all laid out on one slide for you. But let's move on. And here's a table, right? And this table essentially goes over what each model can do given our requirements for our example process. So device read-write, so this is accessing a device in DevFS. Right? You can obviously do all of this as root, as I mentioned before. But POSIX capabilities, they have the F owner capabilities. Pledge promises, you'd essentially give it the Unix scope or Unix, I forget what they call them, but allowing it to do Unix related operations. And then in Capsicum, you'd pre-open your device, and I'll go over that a little bit later more. For socket read-write, you also have the same exact thing. For signals, you have cap-kill, and then you have the pledge proc. Oh, yeah, it's just promise, proc promise. And then shared memory, you have the cap IPC owner, and then pledge does not currently share or allow limiting your scope to allow reading from shared memory regions. And for Capsicum, both of these things are handled by sub-processes, which again we'll get into in the next slides. All right, before I get into Capsicum any further, I know this is a lot of introduction, but you kind of need to have foundations to be able to understand Capsicum fully. One thing I like to point out about both Pledge and the capabilities is they have this kind of like privilege silo. So you have certain capabilities, a certain finite amount of capabilities, and how do you determine what should go into each capability? Some certain things need to be grouped in with other things. And I call these silos, right? So an example of this, in capnetadmin, this is a capability provided by Linux. When you give a process capnetadmin, it gives you all of these things, right? It's not so granular that you can just allow one specific call. It's all grouped inside of this one silo. Same thing goes with setUID. If you just want to give setUID, well, you can't. It also comes with setEUID, setREUID, blah, 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 right? All of that. And then same thing goes with pledge promises. If you give it the inet promise, you're not only giving it access to use sockets, but connect, to get pure name, get sock name, right? You may not want connect if you're just using accept, for example. And then ID is kind of the same thing as setUID, right? So there's this level of granularity that is not optimal with these kind of pledge and capabilities models. Okay. So let's get into capsicumization, which is the reworking of a process to put it into a capability sandbox. So on systems that support Capsicum, so right now it's FreeBSD and there was a Linux port at some point, a program may be sandboxed using capenter, and that's just a simple system call. It takes no arguments, so it's just cap_enter. And we have our traditional hello world here. And you can print to standard out inside of capability mode. Okay, I would like to note here, just to clear up some confusion, maybe you're not even thinking of this, but once we're in our sandbox and we print, we're printing to standard out, right? This means that once we're in our sandbox, we still have access to standard out. And this is an important thing to understand. Once we enter capability mode, we're not giving up anything. We still have everything that we had before we entered. Okay. So after we enter capability mode, it should also be noted that you can't call certain system calls. There are a number that are not permitted. And this is just going over that you can continue to use those resources. And an example of using a resource that was already available before you entered the capability mode was opening the file right beforehand. So say I open something in foo, or in my home directory foo, right? After I entered capability mode, I can read from foo. Traditionally, right, or I guess not even traditionally, just when you're in capability mode, if I did not open foo right here, and I tried it down here, say move this line down here, this would not work because you're not allowed to call open in capability mode. Okay, so there are a number of calls, they're like star at calls that are available inside of FreeBSD, and some are available in Linux. But these essentially allow you to open new files once you're inside of capability mode. And I know that's kind of contradictory to what I just said, but you're using a relative reference, right? So you open home jfree, you only have access to subdirectories under that relative reference point or that relative descriptor, right? So you enter your capability mode. This is now allowed. I can now use open at past the dirfd as a relative reference, and then I want to open bar, right? And I can then open home jfree bar that way. And this allows you to have access to a whole file system sub-hierarchy, right? Which is obviously useful if you're trying to do anything significantly complex. Because a lot of the times you don't know what you need before you enter capability mode. Okay, one thing to note about this is if you open something with a relative reference, you cannot use ... right, to go under that relative reference. So it's only strictly subdirectories of the relative reference, not anything outside of it, which makes sense from a security standpoint. So in short, you just want to open all of your resources before you get into capability mode, and then you won't be able to call anything that would get you in trouble once you're inside of capability mode. It sounds great, right? But sometimes you just don't know what you need before you enter capability mode, right? At some point in your program's execution, you're going to need to run that cap enter, and you can always keep pushing that point back, right, later in execution, but then you're just extending the time that your program is vulnerable. So at some point, if you're going to enter, you need to be certain that you have everything you need before you enter. And sometimes that's just not possible. Sometimes you get some request from the user, you need to fulfill it, and you wouldn't be able to in that case if you're in capability mode. So enter compartmentalization, right? If your entire program is not able to be capsicumized or put into a sandbox, you can compartmentalize it. And I would say if you get anything out of this talk, just the general design of building a program with compartmentalization in mind is a very good thing to think about, right? Because it makes it super easy to basically divide your code up into specific compartments. Say you want to spin off part of your project, you can just have that one compartment that you spin off. Or say one compartment gets a security vulnerability, then the other compartments aren't affected. And this obviously depends on how you design it, but it's a very powerful concept. So compartmentalization is the act of splitting up a program into these different compartments. And you can keep trusted code out of the sandbox this way by, say you have 2 compartments, right, and you only want to sandbox this one, okay, then everything inside of this compartment will be protected and will not be able to access the outside, but this one can still get the resources that it needs to operate. Okay, an example of this is syslogd. So I worked for the foundation to capsicumize or sandbox syslogd. And you can see here, if we look at this yellow part as the security sandbox, then the message processing all happens inside of the capability sandbox, because this is really where all of the intense logic happens, the message processing. Things like configuration handling, you can't do inside of the capability sandbox. I mean, it would be nice if we could, but we just can't, because when you reload the configuration, say you add a configuration line to the end of your syslogd.conf, and it's a new file that you're logging to, once you're inside of capability mode, you won't be able to open that file then, because you don't have access to the open system call. So all of that needs to happen outside of the capability sandbox, and it's done through compartmentalization. Another thing is user-provided command execution. So syslogd also has the ability to, when you get a message of some sort, you also run a command. it's expected, based on how syslog-d has worked pretty much forever, that this command will be run as root, right? And if you're in a capability sandbox, you can imagine you'd run into a lot of problems if you're running the user's command inside of a capability sandbox. So we run that outside of the sandbox as well. And then TTY message and WAL message as well. Okay, so there's an intuitive interface for sandboxing using compartmentalization. And at any point, you can spawn a new child that is inside of this capability mode to protect the sensitive execution from vulnerabilities. So we can get into an example like creating a pipe, forking here, right? And then you cap enter inside of the child process. And then you run your dangerous function inside of that child process after you've entered capability mode. You write to the pipe, and then now you can fetch the result, right? So essentially, all the dangerous stuff happens in here inside of the child process. And everything outside of here is still vulnerable to security attacks, but assuming everything dangerous is in here now, since it's in capability mode, it won't be affected, right? If it gets an attack or a security vulnerability is found, then it's protected by being in capability mode. So you won't be able to call all of the calls restricted by capability mode. All right, so you are probably going to need some sort of refactoring to get this working. From experience, it's not always just like add a cap enter and it's all that easy. But when it's done right, then you now have a compartmentalized architecture, which is great. And it's less work than sandboxing the entire program, right? And sometimes it's not possible to sandbox the entire program. So anything that you can get is an increase in security. And some programs were just not designed to be compartmentalized. So you could re-architect your software, but libcasper, which is a capsicum support library, supports essentially sending things in and out of the capability sandbox without this idea of compartmentalization. So say you just want to enter capability mode for your entire process, and you're not compartmentalizing at all. You can use Casper or a cap channel T and initialize Casper, and you can open a Casper service. In this case, it's the system.net service. And then you can close the Casper service, and this essentially allows you to then enter capability mode and then call networking related commands with the cap underscore prefix to run any restricted commands, right? Usually get attr info would not be allowed inside of capability mode. But in this case, because we have a Casper channel, which we opened here, Casper service open, we can pass that into get attr info, and then it will, if I'm trying to model this out, you can think of this in the underworkings as just very basic IPC wrapper. So you're essentially communicating with another process outside of the capability sandbox. Since you opened that communication channel before you entered capability mode, you still have access to it in capability mode, but you're asking the process outside of capability mode, hey, call get attr info with these arguments. And then you're able to create a socket and then connect to it, which would be things you're regularly not allowed to do in capability mode. So this is kind of breaking our indestructible wall a little bit. And it's not a perfect solution, right? But it's better than not having the wall at all. And you have this like little tunnel here to provide things to Casper and get things back from Casper. Okay, so I just go over here. It provides capability-enabled libc networking functions that would regularly fail with ECAP mode. ECAP mode is the error returned when you raise a capability violation. And again, they're prefixed with cap underscore if you want to use them. Okay, there are a number of other Casper service libraries available. So CapNet only covers the networking related functions. So get, adder, info, any other, I can't think of any right now. But you can see the full list on libcasper man page. Okay, when you want to request a resource from Casper, underneath it's using this capx for NV list. And this gets a little bit messy, but it's really the only way right now to interact with the Casper process, this capx for NV list. And you use NV lists to send things back and forth between the Casper process and your current process that's in the capability sandbox. So let's look at an example of the bind command. When you call cap_bind, regularly bind wouldn't be allowed in capability mode. But in this case, we can create an NV list, and we can serialize the arguments to the command, basically put all of the arguments in an NV list, and then we're sending it over a socket. And then right here, we get the socket back from NV list get descriptor, and then it returns the descriptor that is retrieved by Casper. So it's a little bit messy, but given that Capsicum's supposed to be so security focused, this was kind of the simplest way that we could find to transport certain resources across that Capsicum boundary. It's not supposed to be easy to do this. Okay. So how do you know the command string that you're supposed to use when you're implementing a Casper function? Right here, we just added the bind string to the NV list, and all of the arguments are right here. But how are you supposed to know what the name of the first string is that you put into the NV list? It could be arbitrary, right? In this case, it's pretty intuitive. Bind, it's the bind system call, but sometimes it can be something else. So you're not just supposed to be expected to know this, but when you actually look at the implementation of the Casper service, so this would be cap_net in this case, cap_net provides this net command on the other side. And this is essentially what's run inside of that Casper process when it is launched. And it's just a big line of string comparisons that gives you all of the different kind of strings that you can pass into it. If we go back here, right, we pass that bind into it. Instead, we could have passed connect, get host by name, get host by adder, right? These are all of the calls that are allowed by cap_net when inside of capability mode. Okay. Inside of the Casper code, you'll see this service command func_t definition. And this is essentially what's responsible for parsing that command string. So that would be this signature definition. Okay. And then you also have this create_service macro, which is the glue for everything. So you have the name of the Casper service, you have a limit func, which we'll go over shortly. We have a command function, which is what you just looked at, and then we have a number of flags. And these arguments are gone over in the create_service man page, but when you put this declaration or this macro inside of a C file, it essentially is responsible for creating that Casper service. And an example here might be system.net, right? Net limit, net command. This is cap_net's create_service. I just stole it from the source code. Okay, I know that was a lot. Casper can be a little bit complicated at times, but it's kind of the sacrifice that you're making for ultimate security. But I mean, when you look at the other alternatives, nothing is nearly as flexible. Okay, so now we can go to Casper services are kind of like privilege silos. So we're coming back to the same problem where, if you remember the pledge promises and the Linux capabilities, they have this problem of grouping certain privileges together. Well, Casper is kind of like that, because once you enable CapNet, you're essentially giving access to bind, connect, all of those, right? So we're just looping around to the same exact problem again, which is not great. So that's what the limit func here, net limit, is for. It essentially allows you to limit at a very granular level what calls are able to be made inside of capability mode using that Casper service. So you initialize your limit. You then can limit certain calls, right? Like say you want to limit your name to address to only resolution on freebsd.org on port 80. And you can also limit to just IPv4 addresses, and then you can apply the limit, right? And I skipped over this, but you can also limit specific calls, right? So here we're only allowing name to address. And this kind of solves that granularity problem that the promises and the capabilities have, where you're giving a bunch of different privileges at the same time, given one kind of Casper service or one kind of promise or one kind of capability. In this case, you're able to very granularly limit what your process is able to do. And this is kind of the power that comes with Capsicum. So you can specify that limit func inside of create_service. And when cap limit is set is called by the program, right? So capnet limit will then call cap limit set. They're essentially redirected to the Casper process, which is responsible for processing them and then limiting what the user on the other side, inside of the capability sandbox, will be able to call. And limit functions are very dependent on the Casper service that is calling them. So I wasn't able to find a very standardized example of this, but you can look in libcasper, and services to get an idea of what a limit function might look like. So in all, Casper service is composed of these 4 major components, right? Functions prefixed with cap underscore, so from the program's perspective, that's inside of the capability sandbox and can call any libc call that's provided by the Casper process with a cap underscore command, and that issues those commands to libcasper. It essentially abstracts away all of that capx for NV list. A command func that is responsible for executing the requested call that the process inside of the capability sandbox wanted inside of the Casper process. A limit function that restricts what commands or what calls can be made inside of the Casper process, and the create service macro that glues the service together. Now I want to note here that all of these, right, all of this create service, command function processing, command func, command string, right, all of this is not strictly necessary to know if you're just trying to implement Capsicum inside, or capsicumize your program, if you're just trying to implement Capsicum. If you're just trying to use Capsicum and sandbox your program, you can strictly stick with these cap underscore calls. It's only when you run into a situation where you don't have a call that's provided by one of the libcasper services available, then you might need to go implement a Casper service library and go through all of this messy stuff. But I kind of wanted to get these slides in there because no one has documented this. So having some form of documentation is nice. Okay. So you may remember this table from earlier, and I put the Casper subprocess there. So now you have some context over what is going on there. If you want to send a signal, you can use a Casper subprocess like cap underscore kill, and that will essentially communicate to the Casper process outside of the capability sandbox, send this signal to this process. If you want to access shared memory or get like a shared memory descriptor, you can say, hey, Casper process, can you open this shared memory region and then give it back to me? It'd be like cap_shim_open. Okay, they're pretty rigid, but they provide these capsicumized or these sandbox programs a way to access resources outside of this security sandbox. And when they're used correctly, they can end up with kind of the most secure solution that you would get given all of the other options that you have out there. So that's kind of the goal of Capsicum. At its very base, it's simple. Once you start needing to do more complicated things, then things quickly get complicated. But in the end, you can rest assured that your program is more secure than if you were not using anything at all, or if you were using Linux capabilities, or if you're using OpenBSD promises. Okay, so I should note here that they fail with ECAP mode. I went over this earlier. This is how you detect violations. And with proper error checking, it's difficult to hunt down these capability violations. You'd need to go through your program. You'd need to run it until you get one of these capability violations, and then go fix the error, fix the capability violation, recompile, run again until you get the next capability violation, fix it, recompile, and then just repeat that loop over and over. It's pretty tedious. So when you're trying to capsicumize your program, doing this process is not the most fun thing. Luckily, Ktrace 2, or Ktrace, implements this mechanism to find violations. So you can use this ktrfaq_capfail, and it will detect all of the places in which your program would raise violations. This is something I implemented in the kernel. So here's an example of a program that just raises a ton of violations. It basically does everything that Capsicum won't want you to do, right? You wouldn't want to, or inside of capability mode, you wouldn't be able to expand your capability rights. You wouldn't be able to call FCNTLs. You wouldn't be able to call create raw sockets. You won't be able to create inet sockets. You won't be able to use send_to, use kill. All of these things are not allowed. So when I run this code, given that I started at the very top, I opened ktrace.out, and then now I'm ktracing to it with that capfail flag, I'm getting a list of all of these different points in the program where a capability violation was raised, right? So essentially what it's doing is it sees, okay, capability violation, we're just going to ignore that for now. Capability violation, we're just going to ignore that for now. Capability violation, we're just going to ignore that for now, right? And it just keeps going through the program and prints all of the capability violations that your program might see. And it gives you a description of where it's at, or what it is. So it's just another tool in your toolbox to capsicumize your program. It only takes a few seconds to add that 2 lines to your program, or you can even run with the ktrace command line utility and get the same functionality. But when you do this, you can quickly see, okay, if I don't have very many violations, maybe it might not be so difficult to capsicumize my program. Maybe I should do that to try to maximize security. If you get a lot, then you know that you have a lot of work ahead of you. Okay, so all of these models were designed to make the sandboxing process, or rather security, safer. And you can isolate your program from the rest of the system using this capability mode. And you can always rest assured that it will be safer once you've put it into capability mode than when you had it outside of capability mode before you implemented it. All right. So that was a lot of information, but if you guys have any questions, I'd be happy to answer them.
Question marks come around.
Yep. Right.
So if you're running ktrace, if you open the
if you're using ktrace before entering the capability mode, it's still running, but basically it's not enforcing the sandbox, right? Everything will still run as it would normally run without the cap mode, right?
Right. So if you notice here, this was like the exact program source minus the headers. So there's no cap_enter here. I'm never entering capability mode. I'm basically just saying, hey, look at all of the capability checks that you might run across and just document them when you're coming across them. So if I did a cap_enter here, then I would fail.
Okay.
And the program would terminate.
Is it possible to, and have you quantified how much Capsicum would improve the security of a program? So like by counting how many ECAP modes you get when you just like naively Capsicumize something?
I don't quite understand. Do you mean like the improvement that you'd get from Capsicumizing a naive?
Like, have you Capsicumized a program and seen that it did run into a lot of capability violations?
Yeah, so I Capsicumized unzip, and that was relatively easy. I essentially just needed to open the descriptor of the directory that the zip file was in, and then I was able to extract all of the files to that directory using openat. So that was pretty simple. It highly depends on what your program's trying to do and if it's not allowed in capability mode. But you can get good results relatively easily. There's a FreeBSD forum page that says, here are all of the things in the base system that need to be Capsicumized, and here are all the things that have been Capsicumized. And the list of things that have been Capsicumized is pretty large and didn't require that much effort. But there are some left over that are very difficult and people haven't done. So yes, you can naively Capsicumize things pretty easily if your program's not that complicated.
But I guess my question is, have you found any vulnerabilities by doing this?
Not personally, no.
I'm thinking about something, let's say, a little bit different, let's say, vice versa approach. Whether I can get a precompiled program and just trace it and see whether all of those violations of the capabilities, and later on I decide, for example, that yeah, it's fine to open a file, it's fine to open a socket, but something else is prohibited. How can I do this? I mean, grant some capabilities to the existing program I have.
Yeah, so, I mean, if you didn't have the source and you just ran it, it would essentially tell you everywhere that would raise a capability violation. There's no way to use that mode inside of actual capability mode and then like pick and choose what would be allowed and what's not, if that's kind of what your question is. The idea of capability mode is kind of all or nothing. Right, except for the idea of Casper processes, which is, as you saw, a pretty big and complicated workaround. So yeah, it's not really that easy to pick and choose. And you're not even in capability mode when you're running the ktrace. So, I mean, it might be possible to implement a filter inside of ktrace, but it doesn't exist right now. Okay.
Does Linuxulator implement like Linux capabilities, and does it use Capsicum to do this? Because it sounds like Capsicum is like a superset of everything that Linux capabilities can do.
I would definitely say that, I don't know for certain, but I really highly doubt that it uses Capsicum. Like I'd say 0% chance that it uses Capsicum to implement capabilities. I don't know how we handle capabilities in the Linuxulator. I think we probably just ignore them because they're not strictly necessary. Usually it's like a compile with capabilities type situation. Like, okay, so an example in a C program, you might have like an if-def with libcap, right? And then you put code that uses Linux capabilities inside of that. So it's an optional thing most of the time anyway. And software that I've seen ported from Linux to FreeBSD just doesn't use that capability code. Like, I don't think we have a libcap inside of FreeBSD.
Would it make sense to even use Capscom for this, or would it just be equivalently easy to just implement
I
capabilities?
don't think so. I don't think it would be. It's not a one-to-one match, right? They're doing completely separate things. Like, one is giving more privileges, and one is just essentially not allowing access outside of the capability sandbox, right? So they're just completely different models. It wouldn't be easy. There'd be easier ways to do that. I feel like a from the ground up implementation would just be easier. All right, well, thank you guys for coming.
I just want to give you a little speaker gift.
Okay.
It's a tie for you.
Awesome. Thank you so much. Yeah, for sure.
I know you did which opcodes you're allowed to perform on a file descriptor.
Yes.
Is there something similar for socket options and file controls?
Yes, there is. You can limit the file controls that you do.
And socket options?
I don't know about socket options.
I haven't found anything.
Yeah, I don't think so for socket
There's
options.
not that much, but I just looked it up and thought, that's strange.
Yeah, yeah. I don't know. It'd be unfortunately, support isn't that great. Capsicum was added a long while ago, and it hasn't seen great support. So
Yeah, because it's so damn hard to retrofit to a code base which interacts with the kernel in non-trivial ways.
Yeah.
It doesn't matter how complex your chess engine is, it's trivial to capture the commands.
yeah, I agree.
But if you have a library dependency which insists on opening some file late in the runtime, you're out of luck. You can't just